Hi, grade 11s. Welcome to Spark Genius Academy with Polite Guys. I am very excited that we are finally doing this, a past paper. So this is the Eastern Cape past paper that we're going to work on. So this is grade 11, November 2023, mathematics paper 1. So now, without wasting any time, guys, let's dive into the questions. So let's see what we have. This is question 1. It has to do with algebra. So now, as we go through this question, we're going to also discuss some of the mistakes that you guys make. Let's start with the first one, 1.1.1. So on this one, I have this as x squared minus 3x, and this is equated to 0. This, by looking at the mark equation, the question is saying, buddy, this is just a friendly match. This is just a warm-up. It's a warm-up question. Tells you that you don't have to go into too much detail on this one. It's easy. Look at this. What do we have here? We have the common factors, and we can take out common factor x. So what we're going to do is that if we take the common factor, we'll have x into x minus 1. X into x minus 3. So this is what we have, x into x minus 3, and this is equated to 0. Therefore, remember the zero product property, that if we are multiplying two terms that are equated to 0, we can take the one term equated to 0, or you can take the other term equated to 0. Therefore, if you do that, what will be the value of x this side? The value of x is just 3. So now let's talk about the mark allocations. How are they going to mark this? So it's very important for you to make sure that you take out your common factor correctly, because there's a mark for that, and there will be a mark for these both two x values. So if they both of them are correct, and then you're going to collect a mark. So this is you're going to get 1 mark for the final answer and 1 mark for taking out the common factor. I hope you guys are happy about that. So now, if we keep moving on the next one, this is 1.1.2. Please look at this question. You see, when you have 1.1.2 and it's like this, first thing first, when we work with quadratic equation, I need you to make sure that whatever that you are working on, it is in the form of ax squared. It is in the form of ax squared plus bx plus c. So we need to change this guy and put it in that form. And how can we do that? Multiplying out of the bracket. So the most important thing is to remember that when you multiply out the bracket, let's say we multiply by that x, we need to multiply each term inside the bracket by what? By that x. So look at what we have. This gives us 3x squared, because it's x times 3x. Then we're going to have x times positive 1, which will give us x, and this is equated to 5. Is this in quadratic form? No. We need to bring the 5 to the other side, so that this will be in the form of ax squared plus bx plus c. So this will give me 3x squared plus x minus 5, and this is equal to 0. So now, look at this equation. Can you factorize this? That's what you need to ask yourself. Can you factorize this? No, we can't factorize this. But the best way to do this is to use what? The best way is to use the quadratic formula. Remember the quadratic formula. You can also get it on your formula sheet, which says x is equal to minus b plus or minus the root of b squared minus 4ac, and everything is divided by 2a. So now the value of a is 3. The value of b, there we have 1, because this is 1 times x, which will be the value of b, and this is the value of c. So a, it's equals to 3 B is equals to 1, and C is equals to minus 5. I hope you guys are having so much fun so far, because I'm also enjoying this on my side. So now when I do my substitution, I need to make sure that I substitute this correctly in that equation. So x will be equals to, what is x equals to? Minus b, inside the bracket we put 1. So please make sure that the value of b, you always put it inside the bracket, just in case it is negative, so you don't forget to multiply out your negative, so that you can get positive 1, just in case the value of b here was negative. Then we're going to say this is plus or minus the root of, where there's b, I'm going to substitute the value of b as 1, and this is squared minus 4 into a. What is the value of a? 3. And what is your c? Minus 5. So divide everything by 2 into the value of a, which is 3. Then you can continue work whatever that you have inside the brackets. And what is the value of x equals to? So x will just be equal to minus 1 plus or minus the root of, if you punch in the bracket, this is 1 squared minus 4 times 3 plus times minus 5, which gives us positive 61. That's what we have. Then everything is divided by 6. I think now what you are seeing on the other side, sir, you can leave it from here. I got this. Okay, so do what you do best, punch that on the calculator. So now the most important thing is for you to know that you're going to punch it with a positive and also with a negative. Then let's see what you get. What is the value of x? So the value of x is equals to 1.14, or your value of x is minus 1.47. And that's it for this equation. Let's see what we have on the next one. For this problem, let's see what we have on the next one. So I'm just gonna take this guy here, and because you see now we don't have much space, so I'm just gonna take this guy. Let's take this 1.3. Let's go work it out on our blackboard. So we have 2x squared minus 5x plus 3. We need to solve that, and how many marks? 3 marks. Okay, let's quickly go and work on that guy and see what we get. So we are given that this is an inequality, and which is also one of my favorite questions. So I hope that from today it's going to be one of your favorite also, because I'm going to explain it nice. So now this is 2x squared. 2x squared minus 5x and plus 3, and they say this is less than 0. I need you to pause the lesson here, try to work this thing out, try to see what you remember about the inequalities. What do you remember about the inequalities? Right, so now what I'm going to do, first thing first, let's factorize this guy. I'm going to factorize this. This is 2 brackets which are less than 0. Then this side will be 2x, the other side will be x, and the factors of 3 is just 3 and 1. But now the issue is that, where do we put the 3? On this bracket with the 2x, or should we put the 3 on the other bracket? Because remember, the factors are 3 and 1. Where is the 3 going, and where is the 1 going? So now let's focus on what the sign of the value of c. The sign is positive. What is that telling you? This tells you that both of these terms should be negative, because negative times negative will give us that positive 3. So now we are happy with that, because this will be minus 3 times minus 1. This will give us the value of c to be positive 3. I hope you guys understand that part. But now, where is the 3 going? This side or the other side? So now look at this. Look at this. When I put if I put the 3 this side, what will happen? What is 2x times 3? This gives me 6x. So now remember, if this gives me 6x and we said the 3 should be negative, this will make the 6x to be what? To be negative. So now this guy here will be minus 1, you see, this will be minus x. So when you add this to what, you get minus 7x. Is the minus 7x same as the middle term? No. This tells you that putting the 3 to that other side won't work. That won't work for you. So now let's change and put the minus 3 to this other side, and then I'm going to say I'm going to put my minus 3 this side and my minus 1 this side. So this will be x minus 1, and the minus 3 will come this side, because if I say 2x times minus 1, that gives me minus 2x, and then minus 3 times x, that gives me minus 5x. Are these two giving you the middle term of minus 5x? Yes. Then now that you have these two guys, so we are saying that we have 2x minus 3 into x minus 1, and this is less than 0. So now when it's like this, I know that most of you guys treat this as an equation, and this stops today. Please do not treat this as an equation. So don't say 2x minus 3 is equal to 0 or x minus 1 is equal to 0. Don't do this, because remember, we are here to discuss the common mistakes that you guys do. Please don't treat this as an equation, but the best way to do this is to say critical values. You see, you need to solve this in your mind or somewhere on your question paper, not on your answer sheet. So when I say somewhere, just say, I know that if I say 2x it's equal to 0 and equate this to 0, and if I say minus 1 and equate this to 0, this side I'll have 2x to be 3, and then divide both sides by 2. What is the value of x? 3 over 2, or the other side x is equals to 1. So now the reason I'm saying that don't include these steps on you must not include this whole thing. Don't put it on your answer sheet. You can just write it somewhere where no one is going to see that after you are done writing. Right. So now when you are done and you have it in like that, I need you to focus on this part. X is 3 and x is 1. So 3 over 2, I think that's about 1.5. So if that's about 1.5, so 3 over 2 is greater than 1. So you're going to write this and say, see this, you start with the small number, which is 1. Okay, I'm not gonna use big bracket, because remember the sign is less than only, it's not less than or equal to, so these values are not included, so I'm going to use big brackets. But if it was less than or equals to, I was gonna use that bracket to show that my CVs are included. So now you start with the small number, which is 1, and then you write the 3 over 2, you close the bracket. You say these are my critical values. So when you have your critical values, what do you do next? You can just write down your number line, start with the small number, and then on the other side write your 3 over 2. So now let's plot this number. Look at the value of a. The value of a is positive. And what type of graph is this? It's a parabola. It's a quadratic equation. So the value of a is greater than 0. What is this telling you about the shape? It will be concave up. Then I'm going to draw my graph and say this is how my graph will look like. It's concave up. So now the question is asking, where is this less than 0? Where is this negative? So to find the values where it's negative, I need you to choose any number between, you can choose any number between these 2 points, or you can choose any number from 1 going that side, or you can choose any number from 3 over 2 going that side. So now I know that if I have 1 and 1.5, is going to be difficult for me to choose any number between those two numbers. So I'll just go with any number. I can take one number this side, which is 0. Remember, 0 comes before 1. So now I can take 0. So I'm going to take that 0 and substitute it where? on the original equation, this original equation. So when we put 0, what will be the answer? You just have to punch that on the calculator. You can see this is 0, this will also be 0. The answer is 3. So since 3 is positive, just know that this other side also will be positive. The middle side is the one that will have a different sign. So the middle part is the one that will be negative. So what I'm trying to say is that if this side, the sign of that side will be the same as the sign of that side, and then the middle part will have a different sign. And then now you can answer the question, for which values of x is this less than 0? It's less than 0 from this point going in that direction, and it's also less than 0 from this point going in that direction. So what will be the final solution, ladies and gents? So x must be less than 3 over 2, or x must be greater than 1. And if you give them this answer, they're going to give you your full mark. So you can write this and say x must be less than 3 over 2, or x must be greater than 1. So this is the answer that you can give them. Right, then when you have it like that, you can also start smiling and say, you know what, I have that 3 marks. Get in. It's a ding ding ding. Okay, so now if we go back to the past paper, let's look at what we have next. 1.1.4. So on 1.1.4, they want us to solve for x, and this has to do with SATs. So now, how do you solve SATs? That's what I need you to ask yourself. How do you solve SATs? What is the aim? So we have this as 2 root x plus 2 is equal to x minus 1. How do you solve SATs? That's what you need to ask yourself. What is your first aim when you're solving the SATs? This is 1.1.4, and we are given to the root of x plus 2, and this is equated to x minus 1. I'm just going to go back and confirm if this is right. Yes, because I don't want to waste time solving on an incorrect problem. Okay, so look at this. I need you to treat this as one term. So this is like a times b. So this whole thing is a term multiplied by that 2. So how can we, what is the aim when we solve for x when we have SATs? Number 1, make sure that you isolate the root. Whatever that is inside the square root, you need to isolate it. But now it's already isolated because we said we're going to treat everything on the left hand side as a term, because that's multiplication. So this will be 2 the root of x plus 2, which is equated to x minus 1. What can we do next? Let's square both sides, because now we need to remove that square root. But now remember, we just said we have a that is multiplied by b. Now what is going on here? We are squaring this. This is the laws of exponents. So this will be a squared multiplied by b squared. So I think the trick with this one is for you to remember that this 2, it will be squared, and that right. So let me quickly write this in a way that will make everything to be easy for you guys to understand. So this will be 2 squared multiplied by the root of x plus 2 squared. You see, this is x minus 1. I'm just gonna expand this guy. Expand the bracket on the right hand side. 2 squared is 4. The square root cancels. So we need to take the 4 and multiply that 4 by x plus 2. Once you get to this step, you're going to see that no, this question is easy. So now let's do the FOIL method. X times x, that's x squared. Then I have x times minus 1, that's minus x plus 1. So multiply out to the bracket this side by 4, which is 4x plus 8. It's equals to x squared. I can add the like terms this side, which gives us minus 2x plus 1. So now let's take everything on one side. Let's take these two guys to the right hand side. This side will be left with 0. It's equals to x squared minus 2x. The 4x comes to the other side to be what? To be negative 4x. Then I have the 8 that also comes to the other side to be negative 8. So when you add the like terms, we're going to have minus 2x minus 4, that's negative 6x. Then I have 1 and minus 8, which gives us negative 7, and this is equal to 0. Is this easy to factorize? Yes, because we are going to look for the factors of 7, which is only 7 and 1. So since 7 is negative, one bracket should be positive and the other bracket should be negative. So now if I put 7 this side, I put the 1 this side. Which one is positive? Which one is negative? Right, I know that you already gave me an answer on your side. So we take the sign of the middle number, we're going to give it the bigger number, and then you take that one to be positive, and this is fully factorized. Now you can just use the 0 factor law. The 0 factor law. So this is equal to 0. So x minus 7 is 0, or x plus 1 is equal to 0. So this is x is 7, or the other side x is equal to minus 1. So now my question is that, are we done solving the problem? Is this where we stop? Is this where we stop? No. We don't stop, but we need to check our solution. It's always important for you that to check if there's something that you need to reject. Remember, we have this as 2, which is the root of x plus 2, and this is equated to x minus 1. And we just calculated the value of x to be 7. Was that 7? Yes, the value of x to be 7 and the value of x to be minus 1. We need to check which one is true for this equation. So where there's x, we substitute 7 and see if the left hand side is equal to the right hand side. So this will be, if x is equals to 7, I'm going to have this as 2 the root of what? What is x plus 2? This will be 7 plus 2. Then this is equated to 7 minus, what is this? 7 minus 1. So this will be 2 into the root 9. It's equals to 7 minus 1 is 6. And this will be 2 times the root 9 is 3. This is 6. So 6 is equals to 6. Therefore, my left hand side, it's equals to right hand side. It's a ding 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 for 7. For x it's equals to 7. So I'm going to accept this solution. Then I need to test for if the value of x is minus 1. This will be 2 the root of, where there's x this time we put minus 1 plus 2. And then we equate this to minus 1 minus 1. So this will be 2 the root of what? 2 the root of 1. It's equals to negative 2. And then the root of 1 is just 1. So 2 is equal to negative 2. That's not true. 2 is not equal to negative 2. Therefore, we conclude and say x must not be equal to that minus 1. We need to reject. So after rejecting this, you go back to your solution and say x must not be equal to minus 1. Right. So this is how you solve for x when you have stats. I hope you guys are really enjoying this. Né? So far we only left with 2 questions on question 1. Then it's a ding ding ding. You're going to collect the 6 and the 5. Let's see how to collect these 2 marks. Okay, solve for x and y simultaneously. So I'm just gonna write my simultaneous equations that side, and then we'll take it from there. Remember, to solve for simultaneous, we need to first name our equation. So this is x plus 3y is equals to 2. Let's put it on the board. So this is a simultaneous equation, and this is 1.3. I think this is 1.3 or 1.2. Oh, it's 1.2. So we are given x plus 3y, and this is equated to 2. So I'm going to call this my equation 1. Then the next one that we have is x squared minus 3xy. Let's equate this to 4, and this is equation 2. I'm just gonna go back and verify if everything is right, because this is what you need to do also when you are on your exam room, because you can't waste time solving a wrong equation. You copy the wrong equation on your answer sheet. So now I can see everything, it's good. Let's go back and solve. So you're going to check between these two equations which one is the linear one, equation 1. Then you're going to make one variable the subject of the formula, and I can see that it's easy to make x, so I'll take the 3y to the other side to be negative. So this tells me that equation 1, I can write that as x is equals to 2 minus 3y, and we're going to call this equation 3. So now we know what is x. What can you do? You take this value of x, you substitute it back on equation 2. Where there's x on equation 2, we need to put 2 minus 3y. So let's quickly work on that. So where there's x, I have x squared minus 3xy, it's equals to 4. This is my equation 2. So I'm just gonna indicate where there's x. This has to be 2 minus 3y. This x has to be that 2 minus 3y. Let's quickly work on that. Let's substitute everything there. So this will be 2 minus 3y, and this is squared minus 3. Inside the bracket, I need to put 2. What is this? Okay, I'm going to make this more simple, because I know that first thing first, I can multiply the 3 with that y. This will be 3y. Then I open the bracket and put my 2 minus 3y, so that I can just multiply out the bracket with that 3y. Imagine you multiply out the bracket with 3, then when you are done, you're going to multiply out the bracket again with y. You see that there will be some, maybe you might make a mistake somewhere somehow. So now when I have it like this, I can just solve for y. So let's first expand this guy here, 2 minus 3y. This is, oh, we are expanding that, so this will be 2 minus 3y minus 3y into 2 minus 3y, it equals to 4. So I'll try by all means that we move step by step on this one. So let's multiply out the bracket. So when we multiply out the bracket, this 2, it's 4. Then we need to multiply this 2 again with what? With the minus 3. Then you take this, you multiply, then again we multiply that with minus 3. Let's quickly work on that. Okay, so now 2 times 2 is 4. This gives me 4. And then I'm going to have 2 times minus 3y, which is 6. Then I will add that to 2 times minus 3y again, which gives us minus 6y. So I need you to pause minus 12y. I need you to pause the lesson, do your FOIL method, and verify if this is right. So this will be minus 2y. Then now we're going to say minus 3y multiplied by minus 3y, which is positive 9y squared. Then now we need to multiply out the bracket. But guys, it's very important for you to understand that when you multiply the bracket, we also consider that sign. So you're going to multiply with what? You're going to multiply there with the negative 3, 1. I hope you guys are happy with that. We multiply with minus 3y, not only 3y, but we also consider the sign. So this will be minus 3y multiplied by 2, which gives us minus 6y. Then I'll have minus 3y times minus 3y, which gives us positive 9 squared. 9y squared, it's equals to 4. So do we have the like terms here? Do we have the like terms? Remember, how do we see the like terms? The one that has the same variable and the same degrees. So this is y, which is to the power 1, and this is also y, which is to the power 1. So these two guys will be the like terms. So when I say minus 12y and minus 6y, this will give me a negative 18y. Then now the 9 and that 9, they are also the like terms because they both have y squared, y squared. When we add them, since the sign are the same, this will be 18y squared. Now, what about the 4 and the 4? So look at this. The 4 and the 4, they are in different signs and they have same signs. So the 4 can come this other side to be negative 4, which will cancel that 4. So this 4 and that 4 will cancel each other because the 4 will go to the other side to be negative to subtract that other 4. So now let's currently write down what we only left with when we added the like terms. So we're going to say we have that 18y squared. So this is my 18y squared, and then we need to subtract 18y and equate this to 0. I think now you guys understand what happened to that, to the 4s. They cancel each other. So how can we factorize this? We can take y as a common factor, but the factor is not just y, it's 18y. So I can take the 18y as a common factor, then I have this as y minus 1. Right, y minus 1 is equal to 0. To solve for x, remember we are multiplying two terms. I can say 18y is equal to 0, or y minus 1 is equal to 0. Therefore, what is the value of y this side? Divide both sides by 18. We have y to be 0, or the value of y is equals to 1. This is our values. The value of y as 0 and the value of y as positive 1. How can we find the corresponding y values? Remember, we already know the corresponding x values. We need to find the corresponding x values, and we already know that x is equals to 2 minus 3y. Where there's y, we can substitute y to be 0, and remember the value of y, the other value of y was 1. Let's quickly go and verify. Y is 0 and y is 1. So we're going to use those y values to find the corresponding x value. I'll start with y to be 0. So my x will be 2 minus 3 into 0. This will just give us x to be just 2. Then we need to do the same and say x is equals to 2 minus 3y. This will be 2 minus 3 into 1. And what is that equals to? 2 minus 3 is just minus 1. So the value of x will be minus 1. So this tells us that if the value of y is 0, the value of x will be 2. And if the value of y is 1, the value of x will be minus 1. And that's it for this one. I'm sorry, I think we, on the previous question, we forgot to indicate the mark allocations. Now, I think we forgot to indicate the mark allocations. But now, when it comes to simultaneous equation, the most important thing, first thing first, to make equation 3, there's a mark for that, and to substitute this correctly on that equation 3, there's also a mark. So far you'll have 6 marks. Né? So most of the time when I still remember this, they also mark the standard form. When I say the standard form, the quadratic standard form, if you can manage to get to that step, there's another mark. And then both of these values, the x and y, there's also a mark There's 1 mark for both of these values. There's 1 mark for that. And then there will be another 1 mark for both y values, the x values. There will be 1 mark. Let's count how many marks. 1, 2, 3, 4, 5. Where is the other? Where is the last mark? Oh, the factors, for taking out the common factor, because this is what they call it, the method. So for taking out the factor, there's another mark. And that's it for this problem. Let's see what we have on the next one. 1.3. So on 1.3, they say that determine the values of p for which the roots will be non-real. So you need to ask yourself, what are we referring to when we say something is non-real? How can we get non-real? Remember, if I have a square root, okay, the square root of negative number is non-real. So we need to find a way to introduce a square root in that equation. To find a square root, then whatever that will be inside the square root, we're going to say it must be less than 0. So if I have the square root of, let's say, the square root of a, since a is inside the square root, so for this to be non-real, a must be less than 0. So my question is that, how can we introduce the square root? If I have x minus 3, and this is equated to what? To p squared minus 4. The x minus 3 is squared. How can I introduce there? How can I introduce there the square root there? I can square both sides. I can square both sides. Therefore, what is this equals to? This will give me x minus 3 is equals to the root of what? The root of p squared minus 4. So I can bring the x to the other side and say x is equals to the root p. Oh, if I bring the 3 to the other side, the 3 will be positive. So this will be 3. Then we say plus, right? So now let's fix something here. Now remember, the square root of any number in math is plus or minus. So if I square both sides, this will be plus or minus the root of p squared. So this one will be 3 is plus or minus that root of p squared minus 4. Did we answer the question yet? No, because the question said for which values of p. Now we need to find p. We have x, we need to find p. This will be non-real. Remember, I said for non-real, take whatever that you have inside your square root. What do you have inside the square root? We have p squared minus 4. Then that p squared minus 4 has to be less than 0. So what I'm trying to say is that to solve this problem, you need to say your p squared minus 4 must be less than 0. Then solve for p. So p squared must be less than 4 because the 4 goes to the other side to be positive. Then you can square both sides. Right, but remember, the square root of any number, the square root of any number is plus or minus. Right, so this tells me that if it's plus or minus, this has to do with inequalities. Yeah? This has to do with inequalities. So I think it's best if we solve this problem as an inequalities. What will you do if you solve it? Because it's an inequality, you can factorize this to find your critical values. This will be p, this will be p, and the factors of 4 is 2 and 2. One side is positive, the other one is negative, and they should be less than 0. Okay, so now remember, I said write this down and say see this, then put the small number. If we solve this, we're going to have a negative 2 as the answer and positive 2. These are my critical values. I need to do what? You need to draw the graph. It's very important that you draw the graph to find the exact solution. So now this is minus 2. I have that as 2. And the value of a here is positive. Your graph will be concave up. Remember, you can choose any number between. So when it's like this, I can choose 0. I always like to choose 0. So the middle part, I can choose 0 and substitute that 0 in this original equation. So when you put 0, you're going to have 0 squared minus 4. So the answer is negative. This tells you that the solution in between is negative. So remember we said if the middle part is negative, what happens about the other side? The other side will be positive. So this will be positive and that will be positive. So the question is asking for which values of p is this. For this to be non-real, the values of p must be less than 0. Less than 0 means what? Negative. So this will be from this point going in that direction, and this will be from this point in that direction. So p must be less than 2 and greater than minus 2. So this is the solution that you need to give them so that they can do what? So that they can give you your 5 marks. Because why? You deserve it. For writing all this on the paper, you definitely deserve that 5 marks. And that's it for question 1. I'm happy that we've managed to push so far. Okay, so now let's work on question 2. Let's see what we have on question 2. Simplify fully without the use of a calculator. So the first question, which is this one, it has to do with exponents, the laws of exponents. So now, if you are not familiar with the laws of exponents, my advice is that pause the lesson, go and revise the laws of exponents. Okay, let's take this equation and write it on the other side, then we'll work on it. Né? So now, what are you given on that equation? I'm just going to write the equation, then we'll simplify it. Okay, so now to simplify this, we are given this is 2.1. Okay, so on 2.1, we are given 2 to the power n plus 1 and minus 8 times 2 to the power n minus 3, and everything here is divided by what? 2 to the power n minus 2. Okay, so when it's like this, look at the 2's. Everything is to the power 2. I mean the base. Most of the time we have the base 2. But now look at this. 2 to the power n, to the power n, to the power n. So when most of the time you have a base that has the same exponent, you check the variable. This tells you that you need to solve this by taking out the common factor. So now you know when to take out the common factor. If you have, let's say I have 3 to the power x, 3 to the power x, 3 to the power x. So now this tells you that we need to take out the common factor. So now how do we take out the common factor if we have the problem in this form? Make sure that the first law of laws of exponents is that if we have the same base, if we are multiplying the same base, what do we do to the exponent? We add them. So when they say we add the exponent, I'm going to reverse the law, because now the equation is given in that form, which is 2 to the power n plus 1. I'm going to reverse this and write it in that form. So now what I'm trying to say is that the 2 to the power n plus 1, we can write this as 2 to the n multiplied by 2 to the power 1, because the base were the same, the exponent were added. So I can write this and say this will be 2 to the power n multiplied by 2 to the power 1 minus 8. I'm just going to leave the 8 like that. I'm not going to change it into base 2. Multiply the 8 by, I need to reverse this again and say this is 2 to the power, this is 2 to the power n multiplied by 2 to the power negative 3. Because if I have 2 to the power n minus 3, I can write this as 2 to the n times 2 to the negative 3. Because if the base are the same, we add the exponent. Okay, let's do the same on the denominator. This will be 2 to the power n times 2 to the power negative 2. Now, do we have a common factor on top? Yes, which is 2 to the n. So now, what I need you to do is that where there's to the power n, you're going to replace that by 1. When you take it out as a common factor, where there's 2 to the power n, what do you put? You're going to put 1. So what is this equals to? This will be 2 to the power n into 2 to the power 1 minus 8 times 2 to the power negative 3. So what I did is that where there's 2 to the power n, we put 1. Maybe we should also indicate that on our equation so that you guys can get this right. We're saying that where there's 2 to the power n, what do? We put 1. So I'm just going to put this as 1 multiplied by, this will be 2 to the power 1 minus 8 times 1 times 2 to the power minus 3. Then everything is divided by what? 2 to the n times 2 to the minus 2. Right. So what happens here is that this 2 to the power n cancels with that 2 to the power n. Then we can solve the top part first and then the bottom part. So look at this. We have 2 minus, let's change this. Remember they said without using a calculator, I can change this 2 to the power minus 3. Remember, if I have x to the negative n, I can write this as 1 over everything without the negative. 1 over everything without the negative exponent. So now we can write the inside and say this is 2 minus 8 times 1 over everything without what? Without the sign, which is just what? This will be 8. We know that now the 8 will cancel and we'll be left with 1. So on bottom we can do the same. This is 1 over everything without the negative. So let's work out on the top part. So this is just 8, which will cancel with that 8. The top part is just 2 minus 1. The bottom part is 1 over 4. So the bottom part is 1 over 4. So 2 minus 1 is just 1. And then it's 1 over 4, which can be written as 1 over 1. Then we are dividing this by what? We are dividing this by 1 over 4. Then this gives us 1 over 1. We change the division to multiplication, but we multiply by the reciprocal of 1 over 4. Therefore, your final answer is just 4. I hope you guys are happy with the steps that we did on this one. Let's look at what we have on the next question. Solve for x, and this one we are given, they want us to solve for x, where you have x, the root of 27 is equals to 2187. So now this is 2.2.1. So remember, I'm going to apply the laws of exponents here, the laws of exponents. So I'm just gonna first start by removing the sat. So I'll definitely remove that sat, and now let me remind you how we remove the square root. So if I have n and then this is the root of x, this can be written as, what is this equals to? Remember, the x is to the power 1. So I can write this as, this will be x, then whatever exponent that you have inside the square root comes on top, it becomes your numerator, and then we're going to divide by whatever exponent that you have outside. So this is what we're going to do. The 27 is to the power 1. So this tells you that we can write this as 27, the exponent that is inside the square root, the exponent that is inside the square root comes on top, and then this is like that. Right. So when it's like this, remember this equation is equated to what? This is equation, it's equals to 2187. So now I need you to punch 2187 on your calculator, and then you say 2187 equals sign, then shift fact. You're going to see that this 2187, we can write it as 3 to the power 7. And then now, since this is to base 3, we need to also change the 27 to be base 3 so that the exponents can be the same. Okay, so now what happens if the exponents are the same? The base, so that the base can be the same. If the bases are equal, the exponents are also equal. So I can write this as 3 to the power 3. Do the same. Say 27, punch equal sign, then say shift fact on your calculator. So the fact is something like this. You're going to see it like this, or you can look for the weight fact on your calculator. So now this will be everything to the power 1 over x. Can we multiply the exponents? Yes. What is 3 times 1 over x? Is just 3 over x. So this will be 3 to the power 3 over x, which is equated to what? To 3 to the power 7. The base are the same, and if the base are the same, this base are the same, this tells you that the exponents are also equal. So now the aim is to solve for x. So now when I have it like this, I can just multiply both sides by what? By x. This will give me 3 is equal to 7x. Divide both sides by 7. What is the value of x? X is just 3 over 7. And ladies and gents, this is your final answer. It's a ding ding ding. Okay, so that's how you solve 2.1. So the aim here was to make sure that you first remove the sets. You need to remove the square root. So after removing the square root, another thing here, make the base the same base. And then now the base are the same. When you get here, the base are the same. Equate the exponent. I hope you guys understand what is going on. So now let's go back to this 2.2. Let's look at this 2.2 now. What do we have then? We are going to solve for x, and you're going to learn something on this one, which is what we call the K method. But now, how do we know that we can apply the K method on this question? How do we know that? Look at this. I have this equation in this form. So I need to solve for x, and for this 2.2.2, what I'm given is 4 to the x minus 16. It's equals to 6 times 2 to the x. So now when I see an exponential equation, that's the first thing that I check. Can I apply the K method? So now you need to know when do we apply the K method. So let me explain when to apply the K method. If you have same base, let's say you have the same base. So base 1, let's call this base 1. The first base is 2x and the second base is x. So when you have these two guys, just know that this is a K method. So now, do we have the same base here? Not yet. So can you see this is 2 to the power x? So this will be my base 2. 2 to the power x, what is that? This will be my base 2. So now my base is 2 and my exponent is x. So base 2 has what? The exponent x. So now I need to test if I can make base 1 to be what? Base 1 to be 2x. Look at another base that has to the power x, which is 4x. How can we change 4x? We can change that 4 first and write it as 2 to the power 2, and everything is raised to what? Everything is raised to x. Then we minus 16. It's equals to 6 times 2 to the x. So now can you see that when we multiply the exponent, then we're going to get this as 2 to the x, then minus 16, it's equals to 6 times 2 to the x. So now when you have it like this, the same base, one has 2 to the x and the other one is x, then this is how you know that this is the K method. So now when it's like this, I need you to arrange that guy here, that this guy, you see the one that is to the power 2x, you're going to write it as 2 to the x, take out that 2 outside, because if you multiply the exponent, you still have the 2 to the x, and we minus 16, we minus 6 to the power, this is equal to 6 to the power 2 to the x. The aim was to make sure that the 2 to the x and the 2 to the x are the same. That was the aim. So now we have this, which is equals to that. Okay, we have this and these two are equal. So since they are equal, we can let k to be that, what? To be 2 to the x, meaning that on the equation where there's 2 to the x, you're going to substitute k. So we're saying that we let k, okay, let k to be that. So now where there's 2 to the x, we put k. This will be k squared minus 16, it's equals to 16k. Let's bring the 16 this side so that we can form a quadratic equation, and this is minus 16. Right, I'm not sure where is the 16 coming from now. I'm not sure where is the 16 coming from. So now I think you guys can see how easy it is for you to make mistakes in an exam. Now, I'm not sure where is the 16 coming from. Instead of 6, I set 16. Let's rewrite this. Where there's k, where there's 2 to the x, we substitute k. So this will be k squared minus 16, it's equal to 6 times k. So this will be k squared minus 6k minus 16 is equal to 0. So now I'm just going to bring my equation here. I have this as k squared minus 6k minus 16 is equal to 0. Can we factorize this? Yes, we can. So let's open the brackets. The other side is k and the other side is k. Then I need to find the factors of 16 that when I add or subtract them, I get the middle term of 6, which is 8 and 2. So this is 8, this is 2. So now since 16 is positive, the other one will be, the other bracket will be positive and the other bracket will be negative. So we take this negative, we give it the bigger number, this will be positive, and remember this is equated to 0. Right, so when it's like this, I can just say k, it's equal to 8, or the value of k is negative 2. But when I have it like this, remember the question said solve for x. Where there's k, now I can put back the 2 to the x, equate this to 8. Let's solve for x. So this will be 2 to the x. We make the base the same. We write the 8 as 2 to the power 3. The base are equal, therefore this tells us that the exponents are also equal. X is equals to 3. Or this side where there's k, I'm going to put 2 to the x, equate this to negative 2. So now a quick tip is that each and every time you have a number that is raised to a variable, which is this one, then it's equated to a negative number. Just know that this is impossible. This is not applicable. No solution. I hope you guys understand how to solve for x using the k method. And that's it for this question. Okay, so now let's look at the next question. They say that we are given that x is equal to the root of 3 minus 2. Simplify the following without using a calculator. So I'm just gonna okay, they also say give your answer in the simplest sat form. So let's take this guy here and rewrite it on our blackboard. Let's write this on the board. What do we have there? We are given x squared this is question 2.3. On 2.3 we are given x squared plus 1 everything divided by x squared minus 5. So now if we go back to the question, they are telling us what is the value of x. It's root 3 minus 2. Root 3 minus 2. So this x, it's equals to root 3 minus 2. We need to simplify that. So the best way to do this, remember, they tell us that x is root 3 minus 2. So what I'm going to do, where there's x, I'm going to substitute that root 3 minus 2 and see what I have. So I'm going to say this is root 3 minus 2, close the bracket, squared, plus 1. So where there's x, I just put what? Where there's x, I just put the root 3 minus 2. This is also squared, minus 5. So now, can you see that we can work out this equation? Let's first start by expanding the top part. So this will give me the root 3 minus 2 into the root 3 minus 2, because that's what the exponent is saying. Multiply whatever that you have inside the brackets. Then we add 1. Then everything is divided by, the top part gives us the root 3 minus 2 and the root 3 minus 2, then minus 5. So I'm not going to stress myself because I know that whatever that we're going to get inside these two brackets, whatever that we get there is the same thing as what we're going to get in these two brackets on the denominator. So I'm just going to work one of those and then write the same answer. So let's multiply out the bracket. So remember the FOIL method. Root 3 times root 3. Then we take the root 3, we multiply by minus 2. Then we do the same, this times that, then this times that. So on this one, I'm not going to jump any step. Né? So I'm just going to remove that. And then let's work on it. So I'm going to take this step by step. I'm going to say root 3 times root 3 is just 3. Because remember, if I say root 3 multiplied by root 3, the base that is same, this is the same as saying 3 to the power 1 over 2 times 3 to the power 1 over 2. The base that is same, we add the exponents. So this is just 3 to the power 1. So even if you just use your calculator and say root 3 times root 3, this gives us 3. And then we're going to say root 3 times minus 2, this will give us negative 2 root 3. Then I do the same, multiply the minus 2, multiply each term on the other bracket by minus 2. So this will give me minus 2 root 3, then minus 2 times minus 2, that gives me positive 4. Remember, we still have plus 1. Right. Then I'm not going to waste any time on this one. Let's keep this one aside for now and add the like terms here, because I'm trying to understand the green part, what is that equals to. So this will be 3. These two are the like terms. We can add these two. It's minus 2 minus 2, which gives us minus 4 the root 3. Then now I know that this is equals to what? It's equals to those root 3 minus 2 into root 3 minus 2. So this is equals to that. So if I go back to my problem, now I can just substitute that. I know that my problem will be 3 minus 4 root 3, then we add 1, and then everything is divided by 3 minus 4. We said this is the same, né? It's going to be 3 minus 4, the root 3, then this time we minus 5. So what I'm trying to say is that this part here, it's what we got when we multiply out the brackets. This part here It's what we got when we multiplied out the brackets. I hope you guys are happy with that. So now I'm going to add the like terms. So when I add the like terms, I have I think we forgot to write the plus 4 there. We forgot to include this plus 4. So I'm just going to put it there on top, and we also have to put it on bottom. Let's fix that part. This should be plus 4. This here it's plus 4. So I'm just going to put plus 4 there, and then plus 4 there. And then we say we add 1 on top, then we minus 5 on bottom. So this part is what we got when we were multiplying out of the brackets. This is what we got when we were multiplying out the bracket. And we were supposed to just add the like terms. The 4 and the 8 is fine, but the 4 and the 3, we're supposed to add that. So let's add the like terms. 4 plus 3, then plus 1, that's 8. It's 3 plus 4 is 7 plus 1. So this will give me 8 minus 4 root 3 on top, divide by 3 plus 4. 3 plus 4, that's 7. Then we're going to minus 5, that's 2. So we're going to have 2 minus 4 root 3. So is this in simplest form? No. We need to rationalize the denominator, because I don't need to have the SAT on my denominator. So I'm just going to try and rationalize that. Remember, how do we rationalize the denominator? So to rationalize the denominator, this is how you rationalize. You multiply top and bottom by this denominator with a different sign. So we're going to say this is 2. Instead of negative, we say plus 4 root 3. That's how you rationalize the denominator. And this is divided by what? This is divided by 2 plus 4 root 3. Because if you can see that these two cancel, is just 1. So we did not change. We didn't change anything on this equation. The equation is still the same. So when I have it like this, so remember, this is 8 minus 4 root 3 multiplied by 2 plus 4 root 3, and everything is divided by 2 minus 4 root 3, which is multiplied by 2 plus 4 root 3. You just have to multiply out of the bracket and then take it from there. So let's quickly multiply the top part. I'm going to say 8 times 2, then 8 multiplied by that. Then this times that, this times that. Then you do the same on the denominator. So let's work on this one. What do we get there? 8 times 2, that's 16. And then 8 times 4 root 3. It's like saying 8 times 4 root 3. So this tells you that you need to multiply what? So you need to multiply the 8 with the 4. So this will give me 32. So this will be plus 32 root 3. Then minus 4 root 3 times, what is this? Okay, minus 4 root 3 times 2. That gives us minus 8 root 3. Guys, when I say minus 4 root 3 multiplied by what? We are multiplying this by 2. So you just have to say 2 times minus 4, which gives us minus 8. Then we still have the root 3. I hope you guys understand what's going on here. Then I'm going to say minus 4. I need to take the minus 4 root 3, multiply that by 4 root 3. So it will be minus 4 times positive 4, which gives us minus 16. Then I'm going to say root 3 times root 3 is 3. So we need to multiply that 16 by 3. Then everything is divided by We do the same this side. 2 times 2, that's 4. 2 times 4 root 3, that's 8. So this will be positive 8 root 3. Then we need to say minus 4 times minus 4 root 3 times 2, that gives us minus 8 root 3, and then minus 4 times minus 4 root 3 times 4 root 3. So this gives us minus 4 times minus 4, we said that's going to be negative 16. Root 3 times root 3, that's positive 3. So these two here cancel, and then these two here are the like terms, and also the 16 and the 16 times 3 are the like terms. This and that are the like terms. So let's work on those terms. So first thing first, we're going to have 16. Okay, 16 minus 16 times 3. What do you get on that? So 16 times 3, then we're going to minus 16. So 32 minus 8, I know that's 24. So this will be 24 the root 3. And then we have 16 minus 16 times 3, which is minus 32. Divide everything by 4. Okay, let's say these two guys, they cancel because these are the like terms with different sign. Then I have 4 minus 16 times 3. 4 minus 16 times 3, that's because 16 times 3 is 48, then we minus 4, that's negative 44. So now this is in simplest set form because we don't have the set on the denominator. So when you have it like this, someone can still continue working on this, because if this was me, I was gonna just try to impress the marker. Yeah, I know I always do something like this. So now I can still work on this, or you can leave it like this, you'll still get the full marks. But now I can still work on this, because when I look at this, I have 24 and 32. I can take out the common factor there. So the common factor of 24 and 32 there, common factor is 4. I can take out the 4 as a common factor. Then I'll be left with a number that I need to multiply 4 with to get 24. That's 6. So this will be 6 the root 3 minus a number that I need to multiply with 4 with to get 32. That's 8. Everything is divided by. Now I'm going to leave this as minus 44. And then I can still continue impressing the marker and say, you know what? I know that the 4 goes into 44 11 times. So on top, I can say 4 goes into 4 1 times, 4 goes into 44 11 times. Then I can leave this as 6, the root 3 minus 8 over negative 11. Then I can leave my answer like that. Okay, let's see what we have on the next question. Okay, this was the last question for question 2. Let's move to question 3. So on question 3, we are given a linear pattern, and they want us to write down there. They say write down the 5th term, or the 4th and the 5th term of the number pattern. So now first thing first, we need to understand the rule of this pattern. So can you see we start with 17, 14, 11. So this is what? This is descending pattern. So we start with a bigger number, then the numbers are decreasing. So this tells you that to go to the next number we are subtracting, we just have to find the difference between these two terms. So 14 minus 17. 14 minus 17, that's minus 3. So this tells me that when we say, it's like saying T2 minus T1, that equals to 14 minus 17, which is equal to negative 3. So the common difference here is minus 3. The common difference is minus 3. So this tells you that to get to the next term, we are subtracting 3. So 11 minus 3, what do you get when you say 11 minus 3? So this gives us 8. So then the 4th term, which will be my T4, it's equals to 8 and the fifth term, T5, will be 8 minus 3. So 8 minus 3, that's 5. So these are my next two terms. Okay, I hope you guys are happy on that. So let's look at what we have on the next question. They say that determine the general term. We need to find the general term of this pattern. So now remember, the pattern is in the form of the linear pattern. The general term is in the form of a plus into n minus 1 times d. So the value of a is the first term of the sequence. So that 17 is the value of a. So a is 17, and we just calculated d to be minus 3. We can just substitute on the sequence and say Tn is a, which is 17, plus into what is n? We just leave that like that and substitute d as minus 3. So the next thing that you need to do is to multiply out the bracket with minus 3. So this will be 17 minus 3 and minus 3. Then add the like terms. Tn is equals to 17. Okay, let's fix that part. So I think it's best when we keep on making these mistakes now, because you'll be able to fix your mistake. And remember this, I need to pay attention on this. Minus 3 times minus 1 gives us positive. I hope you guys understand what we got there. So this will be 17 plus 3, which is 20. And then the general term will be 3n plus 2, 0. So this is my general term. So that is your general term, and we're going to use this general term to answer the next questions. We're going to use that general term to answer the following questions. So determine the value of T17. So to find T17, remember you have your Tn to be what? You have your Tn to be minus 3n plus 20, meaning that for T17, where there's n, we put 17 to find term number 17. So this will be minus 3 inside the bracket, 17 plus 20. Then you just have to punch that on the calculator to find your T17. So this will be minus 3 times 17 plus 20. And when we put this on the calculator, we get our answer to be minus 31. So this is term number 17. Okay, so now they keep on asking the question that we need to use this general term. So the next question says that determine the number of terms in the pattern. The number of terms. So when they say the number of terms, you're going to say Tn is equals to, you equate this to the last term of the sequence, then solve for n. Then you'll know how many terms we have on the pattern. So what I'm trying to say is that you take your Tn, you equate it to your last term of the pattern and solve for n. What is Tn? It's minus 3n plus 20, and we equate this to negative 247. Let's solve for n. So minus 3n is equals to, the 20 goes to the other side to be negative. So what do you get when you say 247 minus 247 minus 20? This gives us minus 267. Divide both sides by minus 3. Divide both sides by minus 3. Therefore, your n is equals to, remember this is 3.1.4. So your n is equals to what? Your n is equals to, the negative cancel, so this tells us that the number is positive. So minus 267 over minus 3, that gives us 89. So this will be equal to 89. Thus this is the number of terms. Okay, let's look at what we have here. In a linear pattern, this is 3.2 now. In a linear pattern, we are given that the first term is 2x plus 11. This is my term number 1, and the second term is 2. This will be T2, and the fourth term is 2x minus 4. So this is T4, and calculate the value of x. Wait, what is going on here? Let's write our sequence. They say that T1 is 2x plus 11. Then what is the next term? The second term is 2. So now after the second term, I know that I need to have T3 there. Then that's when I can write T4 as 2x minus 4. So we need to calculate the value of x. So let's take this pattern to the blackboard and try to work that out. Right. So when we do this, we're going to say the first term, which was T1, is given as 2x plus 11. Then T2 is 2, and we said we can put T3 there, so that T4 is 2x minus 4. The aim here is to solve what? The aim here is to solve the value of x. So now, what I need you to remember is that this is a linear pattern. So, since this is a linear pattern, what is this telling you? What can you say about that? Remember, if something is linear, it has what? The constant difference. I'm going to explain why are we bringing this. Why do you need to understand that? Okay, so now the aim is to find what? The aim is to find the value of x. But now I know that to do that, this guy is going to be, the difference between these two terms is T2 minus, so this will be T2 minus T1. So my T2 is 2 minus T1 that I need to put inside the bracket. So it's 2x plus 11. This will be 2 minus 2x, then minus 11, which gives me negative 2x, and 2 minus 11, that's negative 9. I hope you guys understand. So this is my difference here. The difference here will be minus 2x minus 9. Then let's find the difference here is T3 minus 2, and the difference here will be 2x minus 4 minus T3. We have a problem. We know that when we work with linear patterns, remember the constant difference, this is equal to that, and this is also equal to that. So all these terms are equal because it's a constant difference, since this is a linear. So to find what is this? To find that the value of x, we can say 2x minus 9 is equal to term number 3 minus 2. Then we solve for x. But now the main problem here is T3. We don't know what is T3. So when you have it like this, now you know what you need to do. To solve this problem, you need to find term number 3. Right. Please pay attention on what I'm about to say now. Please pay attention. Look at this. The 2 and the 2x minus 4. Since this thing is a linear pattern, this tells you that from this point here to that point to that point, this is equal because the difference are equal. What is this telling you? I like what they did on this question, because this is taking you back. Okay, this is taking you to paper 2. This distance here are equal because they have a constant difference. This tells you that T3 is the midpoint of 2 and 2x minus 4. So this is my T2 and this is my T4. Term number 3 is the midpoint. So what we are saying is that if we take T4, we add it with T2, the answer that we get, we divide by what? By 2. This should give us the value of T3. That's how we need to calculate term number 3. So let's add this. I'm going to say 2x minus 4, then I add T2, which is just 2. Divide this by 2, and the answer that I get is my T3. So let's quickly work on that. I'm going to say this is T3. It's equal to 2x, then minus 4 plus 2. This is just minus 2. So this will be negative 2, and everything is divided by what? By 2. I can work with a t that has this kind of a fraction. I can take out the common factor on top and say this is 2 into x minus 1 over 2. The 2 cancels, therefore what is your T3? Is just x minus 1. So this tells me that on this equation here, where there's T3, I can substitute x minus 1. Then I'll only have x on my linear equation to work on. I will only have the variable x. So let's quickly do that. So remember, we are going to substitute from this equation where there's T3, we put x minus 1. So this will be negative 2x minus 9. It's equal to, where there's T3, we put x minus 1 minus 2. So what is this equals to? So minus 2x minus 9, this is equals to x minus 3. Let's group the like terms. So the x comes this side to be minus 2x minus x, it's equal to minus 3. The 9 goes to the other side to be positive. So now I have this as negative 3x, it's equals to positive 6. Divide both sides by negative 3. Divide by negative 3. What is the value of x? The value of x is minus 2. The value of x is minus 2. And that's how you solve this question. I hope you guys are really enjoying this. And let's see what we have on the next one. Oh, that was the last question of question 3. Let's move to question 4 and see what we can, what we get on this one. How many marks can we collect? Obviously, we need to collect all the marks, né? But maybe you might have challenges when you work on 4.2, because I'm looking at 4.2, we are given something different, and you can even look at the mark allocation. But now, hopefully by the end of this, in 10-20 minutes, you will understand how to do 4.4. Then maybe we might increase the probability of you collecting all the marks if the question appears like this. Né? So let's work on it. So now, what do we have on this question? For a quadratic pattern. So let's take our, because I don't think, oh, maybe we do have enough space. Let's write down this quadratic pattern. We have this as 94, 90, 84, 70. Even this one is a decreasing, it's descending, né? It's a descending pattern. So now this tells us that you're going to have a difference that is negative. So now 90, I need to find the difference, the first and the second difference. 90 minus 94, that's minus 4. And then 84 minus 90, that gives us minus 8. And we have 70 minus 84, that gives us minus. When I punch this, I get minus 12. Okay. So now, what is like saying minus 8 minus inside the bracket minus 4? So this is minus 8 plus 4. So the difference is minus 4. Then if this is minus 4, this also should be minus 4. You can also verify that on your side. Now when I have it like this, I can start answering my questions. 4.1.1, determine the next two terms of the pattern. Look at what I'm going to do. I know that the next pattern here, and if I have the next pattern there, I know that the difference between these two patterns is minus 4. So this tells me that on minus 12, I need to add 4, because to find that minus 4, we were subtracting. So it's going to be minus 12, you add 4. This gives us minus 12. We're going to, we add this difference that we get. So it's minus 12, we add minus 4, which gives us minus 16. So when you have it like that, you're going to say, on 70, you add minus 16, because the difference there should give us minus 16. You take 70, you add minus 16, which gives us 54. So the next term here is 54. You do the same to find term number 6. They said find the next two terms. We do the same. This will be, we know the difference, the common difference is minus 4. Whatever that we get here, the difference between then that number should give us minus 4. So we can say minus 16 plus minus 4, which gives us minus 20. Right. So now when it's like this, to find the next term, we're going to say 54, you add that minus 20. So 54, you add negative 20, that gives us 34. So the next term here is 34. So to answer this question, when they say determine the next two terms, the next two terms are, we got 54 and 34. So it's 54 and 34. I hope you guys understand how we did that one. 4.1.2, determine the general term of the sequence. Remember, when you determine the general term, this is my first difference, this is my second difference. So first thing first, to answer this 4.1.2, you need to first start by finding the value of A. So now how do we find the value of A? We say 2A is equals to, we equate this to what? The first term of the second difference. Or let's not say the first term, let's just say we equate this to the second difference. So this is minus 4. Divide both sides by 2. What is the value of A equals to? The value of A is just negative 2. So we're definitely going to use that. I'm just going to highlight my answer because I'm going to need this to work on the next part. So on the next part, I have A. To find the value of B, I use the formula 3A plus B. This is equated to the first term of the first difference, which is minus 4. But now you know what is the value of A, right? Where there's A, you just put minus 2. So this will be 3 into minus 2 plus B is equal to minus 4. So now you just have to say 3 times minus 2, that's minus 6, plus B is equal to minus 4. So we can definitely solve for B by taking the 6 to the other side. So this will be minus 4 plus 6. The 6 is negative on the left hand side. You move it on the right hand side, it becomes positive. So it's minus 4 plus 6, which gives us positive 2. I'm definitely going to highlight that because I need this B for my next problem. So the next one is to find the value of C. So I think the most important thing for you to know is which formulas do we use to find A, which formula do you use to find B. So C, it's A plus B plus C. You equate this to the first term of the sequence, which is 94. So I'm going to equate this to 94 and then work for C. The value of A, we calculated that to be minus 2. The value of B, we calculated that to be positive 2, plus C is equals to 94. So this tells you that the 2 cancels and C is just 94. So now, when you are done with this, you just have to give them what they are looking for, which is the general term. Remember, the general term is in the form of Tn is equal to An squared plus Bn plus C. So I can just substitute my values. A is negative 2. B, we just calculated B to be 2. So it's minus 2 plus 2n plus 94, which was the value of C. So this is my Tn, and I'll definitely highlight that. Why? because I'm going to need this to answer my next questions. Look at what we have on 4.1.3. Oh, 4.1.3. Let's see what they want us to do from that guy. Né? They say that calculate the two consecutive terms whose first difference is minus 136. Okay, so now they said that they want us to find, let's first focus on that. I'm not sure how we can, okay, so let's say this is 4.1.3. Please pay attention on what we are about to do. It's about to go down. Okay, okay, so let's work on this step by step. So we are given that this teeth, we need to find two consecutive terms. What is the meaning of two consecutive terms? The term should be like, if I have 15, the next term should be 16. So it's like T16 and T17. It's like T100 and T101. Two consecutive terms. So now, those two consecutive terms, when you find that their difference, you get minus 136. So what they are telling you is that take the first term to answer this 4.1.3. Take your T, which is that we know that if I have T8 and then after T8 I should have T9. So I know that I'll take the one which is T9 to find my difference, and then I subtract T8. So this tells us that we take the bigger one, we subtract the smaller one. Okay, so now this will be T of n plus 1. Then we need to subtract just Tn, because if I because if this is 8, if my n is 8, I know that this one will be that n plus 1, which is just 8 plus 1 will give me that 9. I hope you guys understand where is this formula coming from. So this, when we do this, we should get the difference as negative 136. Oh, how can we do this? First thing first, we need to find this Tn first. We need to find the Tn first. So this is what we need first. Okay, so on the general equation, I'm trying to go slow on this one. On the general equation, let's go back to our quadratic equation, the one that we just calculated. What was Tn? Tn is equals to minus 2 plus 2n plus 94. Okay, look at what I'm going to do. First thing first, I need to find my Tn plus 1. My Tn plus 1 will be equals to, meaning that on this quadratic pattern, where there's n, I'm going to put n plus 1. So this will be Tn is equals to negative 2, where there's n, we put n plus 1. This is squared, then plus 2 into n plus 1, then plus 94. Then what happens? We minus Tn. What is Tn? Is that general term. I see that we don't have much space now. I see that we don't have much space. I think we should take this thing to the other side, so that, don't worry, I'll write everything down on the board. Remember, we calculated our Tn to be negative 2n squared plus 2n plus 94. What are we looking for? We are looking for Tn plus 1. We minus Tn, and this should be minus 136. So now, first thing first, I'm going to do my substitution on this equation. I need to find my Tn plus 1 and my Tn. So my Tn plus 1 will be negative 2 into n plus 1, which is squared, plus 2 into n plus 1, then we add 94. Then we subtract. What are we subtracting? Our Tn. We know Tn is just 1. I'm just going to put it inside the bracket. Please, this is very, very important for you to remember that the Tn goes inside the bracket because the negative multiplies everything inside the bracket. So this is negative 2n plus 2n plus 94. Then let's first expand the bracket here. This will be minus 2 into n plus 1 into n plus 1. Then we add this to 2 into n plus 1 plus 94. Then I still have minus into negative 2n squared plus 2n plus 94. Then what do we have? This is minus 2 inside the bracket. This is n squared plus n times 1 is n times 1 is n. When you add them, you get 2n, then plus 1. This is what we have in that bracket. Then now the next step will be multiplying out the brackets. Because you know, I'm just gonna focus only on one problem each step because I don't want to confuse you and I don't want to make any mistakes. So now the next step now is multiplying out the bracket. Let's start with the first one. When we multiply out the bracket, what do we have here? This, how many marks are we working for here? 5 marks. This makes sense, nah? No, 4 marks. 4 marks, but still, it's nice. So this is minus 2n squared minus 4n minus 2. So we just multiply everything inside the bracket by that 2. Then we multiply inside the bracket by 2 again. This one, we will multiply by minus 2 at first. Now we multiply by 2. So this will be plus 2n. Then we have plus 2. Then now we have that 94. Multiply the bracket by negative. So each and every sign there will change. Each and every sign will change. Let's check if we have the like terms. So now I'm going to check this. Look at this. 94 is positive and this 94 is negative. So these two guys will cancel. 2n is positive and this 2n is negative. So these guys will cancel. Right. So if we continue doing this, I'm really enjoying this because this makes everything to be easy. These two guys have opposite sign, but they are the same. They will cancel. When we add them, they cancel. Minus 2 and 2 are the same with different sign. They cancel. They cancel. So everything cancels except for minus n. So remember, this is equal to what? This difference is equal to minus 136, minus 136, minus 136, and minus 136. So now this tells you that what we have here is going to be minus 4n. Minus 4n is equal to minus 136. The aim is to solve for n. Minus 4 minus 4, therefore n is equals to, so 4 goes into 136 34 times. So the value of n is 34. Let's go back to what I told you guys about. Remember I said if n is 8, what is n plus 1? It's going to be 34 plus 1. So we know that the next thing that we need to do here is to find n plus 1, which is just 34 plus 1, which is 35. So we can find our T34, T35, and T34. So if we go back to the question, let's try and understand this question. Calculate the two consecutive terms whose first difference. So when we subtract those two, we must get minus 136. So now please don't make mistakes. and say your two terms is n it equals to 35 and 34. No, this is the position. This is like saying T34, and then this is like saying T35. So what they want you to do now is to prove that T35 minus T34 is equal to negative 136. So the term that is T35 is the one that they are looking for, and the term that when we substitute on the general term we get is the one that they are looking for. Let's try and do that. Remember, our Tn is equal to what? Negative 2n squared plus 2n plus 94. That was the general term. Let's first find term number 34. T34, what is that equal to? Negative 2 into 34, and this is squared plus 2 into 34, then plus 94. So T34 is equal to, we just have to punch that on the calculator. So it's 2 into 34 squared plus 2 into 34 plus 94. What is that equals to? So when we put this on the calculator, we get minus 2,150. So now I'm just gonna highlight that guy because this is something that I'll need just to confirm my answer. So now let's go find T35. Let's use the same method. We know that T35, where there's n, we put 35. This is squared plus 2 into 35 plus 94. And then let me punch this on the calculator and see what I get. So the aim here was to find n, and you just have to understand this formula here. Okay, so now what is this equals to? When I put this on the calculator, I get minus 2286. Minus 2286. So now what is this saying? It tells you that when you say T35, you minus T34. Let's quickly confirm that. When we take T35, which is negative, we have 2286, then you minus 2150, you need to get negative 136. So when we say T34 minus T35, we need to get minus 136. So the two consecutive terms are, these are the terms that they are looking for. So negative 2286 minus into negative 2150. When you minus these two, we need to get what? We need to get the answer as minus 136. And that's it for this question. This is how you answer the question. I hope you guys understand each and every step that we did on this one. Let's look at what we have on the next one. They say that a quadratic pattern is a general term of Tn it's equals to an squared plus bn minus 15. T2 minus T1 is 3 and T3 minus T2 is 7. Determine the value of A and B. So I think this one, looking at the mark, we're going to also need the blackboard. So let's quickly work on this one. We are given the general term, okay? And they say this is an squared plus bn minus 15. So now on this one, they say that if we go back to the question, T2 minus T1 is 3. So we are given that T2 minus T1, the answer is 3. And what else do we know is that T3 minus T2, that's 7. T3 minus T2, that's 7. Determine A and B. You know what I'm going to do first? Let me first focus on what I'm given. Let's start with this t2 minus t1 is equals to 3. Let's start with that. So I know that if I have something like that, I need to find my t1, I need to find my t2, and I need to find my t3. How can I do that? I'm given the general term. So now I need to create equation 1 and equation 2, then I can apply the simultaneous equations. I can use simultaneous equation to solve this. So now I'm going to look for t1. For t1, so to find t1, I have to substitute where there's n on this equation, I put 1. This will be a into 1 squared plus b into 1 minus 50. So what is t1? T1 is just equals to, so this is a, because 1 squared is 1, plus b minus 50. But now remember, okay, it's fine. Let's just leave it like that. Let's find t2 now. So this is my t1. That is my t1. I need to find term number 2. It's a into 2 squared plus b into 2 minus 50. So we minus that 15, and then what is this equals to? What is term number 2 equals to? So 2 squared, that's 4. This will give me 4a plus 2b minus 50. So this is my term number 2. I have t, now I know what is t1 and what is t2. But remember, we were given that if you take t2, you subtract t1, you need to get an answer of 3. I'm going to use that information to create my equation 1. So my t2, that's 4a plus 2b, 4a plus 2b, wait, 4a plus 2b minus 15, then we minus inside the bracket. What are we minusing inside the bracket? That t1, which is a plus b minus 15, everything should be equal to 3. So we just have to work this thing out. Now, let's first multiply out the bracket. I'll have this as 4a plus 2b minus 15. Then multiply out the bracket with negative. This is what we have. So now the like terms, 4a minus 3a, 4a minus, that's 4a minus 3, I'm sorry, 4a minus a, that's 3a, and then 2b minus b, that's b. So this will be 3a plus b. What is this equals to? Because the 15 and the positive 15 cancels, we are left with that equation. I'm going to call this my equation 1, or we can also make b subject of the formula, or so that we can know what is b equals to. So we can move the 3 to the other side, or the 3a to the other side, and say b is equals to 3 minus 3a. So this is my equation 1. So now I know what is my equation 1, because we're going to solve this problem simultaneously. So this is b is equals to 3 minus 3a. I hope you guys understand how we got that. We used this information here to create our equation 1. Now we need to do the same, the same, but for this one it's easy because we only need to find our term number 3. We only need t3 because we know what is t2. We need to use that. We know what is t2. So this will be to find term number 3 on the general term where there's a, where there's n, we put 3. So this will be a into 3, which is squared, plus b, which is to the power into 3 minus 15. So what is term number 3 equals to? So term number 3 is just 9a plus 3b minus 15. So now you can see that this is my term 3. Now I need to find what is t3 minus T2. So I know that T3 minus T2, it was given to be what? This is equal to 7. If you still remember, that is equal to 7. So I can definitely say that this is 7. Then my T3, it's 9A plus 3B minus 15 minus inside the bracket T2, which is 4A plus 2B minus 15. So now we can multiply out the bracket with a negative. This is 9A plus 3B minus 15. So the sign changes there. It changes everything inside the bracket. So now remember, this is equals to 7. So what happens next? The 15 cancels because of the signs. And then I have 9A minus 4A, which gives us 5A. 3B minus 2B, that's B. So this will be plus B, which is equated to 7. But remember, we can call this equation 2, and we know what is B equals to. B is equals to 3 minus 3A. 3 minus 3A. So we can substitute B on this equation. So where there's B, we can substitute 3 minus 3A. Okay, I'll definitely work on that and say this will be 5A. Then where there's B, we put 3 plus 3. I'm just gonna put it inside the bracket just in case if the sign here was negative, right? So that you can remember to multiply out the bracket. So this will be equals to 7. Let's solve for A. So this will be 5A plus 3 minus 3A is 7. So 5A minus 3A, what is that equals to? 2A, which is equal to 3. Goes to the other side, that will be 7 minus 3, which is 4. So 2A is equal to 4. Divide both sides by 2. What is the value of A? Is 2. So now that you have the value of A, it's easy for you to find the value of B because you already know what is B. Remember, B is just 3 minus 3A. So B will be 3 minus 3 into where there's A, we need to substitute 2. So where there's A, we put 2. So the value of B will be 3 minus 6, and B is just negative 3. And that's the value of B. So when you have it like this, you're going to collect all the marks. So the most important thing for you is to be able to analyze this part. When they say T2 minus T1 is 3, so you have to find T2 and you have to find T1. How do you do that? You substitute on the original quadratic equation. Right, I hope you guys are enjoying this. So what do we have on the next question? Was that question 4? Now with question 5. Okay, so now let's work on the next question. Let's see what we have on this question 5. It has to do with functions. The diagram below shows the graph of f at x is equals to a over x plus p plus q. So this is hyperbola. The asymptote of f intersect at. So we are given the x asymptote, and we have like the vertical and the horizontal asymptote. So always know that the vertical is in the form of x is equal to, and it's given as negative 3, and the horizontal is in the form of y is equal to, and it's given as minus 1. So f cuts the x-axis at minus 5. So if it cuts at minus 5, the coordinate of this is minus 5 and 0 because the x-intercept if y is 0. Okay, this is what we have so far. This is the information that we have. Let's see what we need to do on the questions. Write down the values of P and Q. Write down the values of P and Q, and for you to work on this type of questions, you know what I need you to do? I need you to first understand how P, how the value of P works. Okay, so the value of P, I'll explain how that works, but now let's start by determining the value of Q. So the value of Q is your, the value of Q is your, what we call your horizontal asymptote. I hope you guys understand. So you just have to take it the way that it is with the sign. So the value of Q is this one, it's your horizontal asymptote. Let me put it here so that you don't forget. Q is your horizontal asymptote. So what will be Q equals to? So Q is given there to be minus 1. Remember, we are saying Q is the horizontal asymptote. That line is your horizontal asymptote. Right, so with P, this is how P works. To find the value of P, when they ask you for P, this is what I need you to do. Take this X value, substitute it as P there. So it's like saying X is equal to P, but your P this time, it's what? Your P is negative. So if your P is negative, I need you to put the P back this side, and we have this as X. Okay, where can we do this? Because we need to save the space for other questions. We need to say this is X, it's equal to minus 3. The 3 comes this side to be positive, so X plus 3 is equal to 0. So this tells you that the X plus 3 is what we need to put on the denominator. So if I rewrite my f at x, I'm going to have f at x, it's equals to a over x plus 3 then minus 1. So when you have it like this, the common mistake that most learners make is to say P is minus 3. That's not true. The value of P is positive 3, because you need to first substitute it back there and see the sign of the P. Please make sure that you follow this part here. You say x is equal to minus 3, which is what we were given. We just say x, we equate to that, minus 3. Then we take the 3 to the other side to be positive x plus 3. So when you put it on the graph, it's x plus 3, so P is positive 3. Because most of learners, when they say P is minus 3, they follow this x is equal to P. That's not how it works. Now, so now the next question, determine the value of A for 3 marks. So we already know our equation and we need to find A. I'm just going to rewrite my equation down here. F at x is A over x plus 3 minus 1. So to find the value of A, we can substitute any value, any coordinate on the graph, and there's one that is given there, which is minus 5 and 0. So this is my x, this is my y. So on my equation, remember this is y. Where there's y, I need to put 0, and where there's x, we need to put minus 5. So this will be 0, A over minus 5 plus 3 with minus 1. So now this is what we call, this is for 5.2, and I'm just going to write it down here, 5.2. So when I solve this, the 1 comes this side to be positive, then I'll have A over minus 5 plus 3, that's negative 2. So when we cross multiply, remember this is over 1. When we cross multiply, the value of A is negative 2. So we have the value of A as negative 2. So to answer this question, make sure that you write all the steps. The value of A is negative. Just don't say the value of A is minus 2, but show all the workings. That's how we answered 5.2. So I'm just going to put my 5.3 down here. And let's see what is 5.3 saying. Hence or otherwise calculate the y-intercept. Hence means that use whatever that you got. So f at x is equal to, I know what is a, I need to go back where there's a, I need to substitute that value of a. Look at this. The value of a, now we know what is the value of a. It's minus 2. You go back on that equation, you substitute it and rewrite your f at x. What will be our f at x? So our f at x is f at x that equals to minus 2 over x plus 3 minus 1. And the question says, hence or otherwise calculate the y-intercept. We find the y-intercept if x is 0, meaning on that equation where there's x we substitute 0. So y will be equals to minus 2 over 0 plus 3 minus 1. So when you punch this, it's minus 2 over 3 minus 1. So this gives us minus 5 over 3. That's the y-intercept. So now remember, we said the y-intercept if x is 0. So the coordinates of the y-intercept will be x is 0 and the y value is minus 5 over 3. And which point here is the y-intercept? This point here. So this point will have the coordinate 0 minus 5 over 3. I hope you guys understand what is going on here. Then write down the domain of f. Remember, this is what? This is a hyperbola. The domain, it takes all the x values, but except for one x value. We're going to discuss which x value. Look at this. My graph, for the fact that it moves like this is 0 now. This is 0. So it takes all the positive x values, because this arrow shows that the graph keeps on continuing. And then this other side also, it takes all, but there's this one, that one x value the graph is not touching. Look at this. What is the x value here? It's minus 3. So the graph must not touch that minus 3. Even this side, if you can check, the graph is not touching the minus 3. So it takes all the negative numbers and all the positive numbers, but it must not touch what? It must not touch minus 3. So with that being said, we can say for the domain, x must be an element of real numbers. An element of real numbers, it tells you that it takes all the positive and y values, but remember, it must not touch that minus 3. X must not be equal to minus 3. And that's it for that 5.4. Determine the line of symmetry of f with a negative gradient. When they say the negative gradient, the formula that we use to calculate the axis of symmetry is going to be y is equal to negative x plus c. Because if I look at this formula, the gradient of the line of symmetry is 1 if m is positive. If m is greater than 0, your graph will be y is equals to x plus c. And then for this one, it's if the gradient is less than 0, because it's given that your gradient must be negative. So we're going to work on that. Don't worry, we're going to solve this step by step. So that is 5.4. So to solve 5.4, you know what I'm going to do? I'm going to say, we know that it's negative gradient, and this is the formula that we need to use. So let's quickly work on that. Y is equal to minus, this will be 5.5. So y is equals to answer 5.5, y is equal to minus x plus c. The aim here is to find c. To find c, you can substitute. You're going to sub in your value of p and q, which are the only point that you are given on the axis of symmetry with a negative gradient. So if it's a negative gradient, your graph will pass like, remember the axis of symmetry, it's a line that divides the graph into two equal parts. So this will divide the graph down there. I'm sorry. So it will divide the graph here and pass through that point. So this one is the one with the negative gradient. If they ask for the positive one, it's the one that will divide it like this. But we are not interested in that one, so I'm just gonna remove that for now. So this one, it has a negative gradient because if you are this one, you're going to walk down the slope. So the slope is negative. So this is y is equal to minus x plus c. Let's find the value of c. We only have 1 point, which is minus 3 and minus 1. So we need to substitute minus 3 and minus 1. We always substitute p and q. P and q. P and q. This is your x, this is your y. So meaning that where there's y, you put minus 1, and where there's x, you put 3. So let's quickly work on that. Where there's, remember, what I'm saying is that you have x, you have y. So where there's y, you put minus 1. And where there's x, you put minus 3. And this is plus c. So minus into minus 3, that's positive 3. Plus c, it equals to minus 1. So the 3 will come this side to be negative. Therefore, the value of c is minus 4. So now, the final answer is y is equals to minus x minus 4. So this is the equation of the axis of symmetry with a negative gradient. Remember, if the gradient is negative, we use minus x, and if the gradient is positive, that will be x. Okay, so the next question is asking for which values of x it's f at x greater than or equals to 0. Let me first explain what is the question asking here. Greater than or equal to 0, they are asking where is the graph of f above the x-axis. Where is the graph of f above the f-axis? So they want to know where is f at x above the x-axis. So now look at this. If I have my x-axis, I'm not sure if you're going to get this because already we have so much information on the board. This is my x. Remember, this is my x. So if this is my x, this point, I'm not sure where I can write this. Remember, if this is my x, from this point here, let me just write this down here. Where is this graph above? So if you have x, how can we put this? Maybe we can just put it here. If this is x, going this side, it's above x-axis, and from this point going down is below. Right, it's below x-axis. So now they are asking where it's f at x above. So you need to look where it's in above. Okay, let's quickly go and check where it's f at x above. So can you see that from this point here, going up there, the graph is above the x-axis. But the graph must not touch minus 3. So we're going to take from that point to that point. So between these 2 points, this is where your graph is what? I'm just going to remove this axis of symmetry. Okay, so those are the one that we are looking for. Those 2 points are the ones that they are asking you to determine. So we said that where it's f at x above, from this point going up, it's above the x-axis, but it must not touch this. So this tells you that x must be less than that negative 3, but it must not be equals to that. It must not be equals to that minus 3. Then it must be greater, because from this point we're going in that direction, it's greater or equals to what? Minus 5. But from this point we go in what? In that direction, it must be less than. So the final answer for this one is x for 5.6. X must be less than minus 3, greater or equals to minus 5. I hope you guys understand that, but if you don't get it, please try to move back, and where we started with 5.6, try to make sure that you get it. It's very easy now. Okay, the last one for question 5, they are asking, describe the transformation of f to g given that g at, so first thing first, I need to know what is my f at x. This is my f at x. That is my f at x. So I'm just gonna rewrite my f at x down. Minus 2 over x plus 3 minus 1. That's my f at x. So to answer 5.7, my f at x is equals to minus 2 over x plus 3 minus 1. So I need to compare my f at x with g at x, because I need to understand what happened on these two graphs. How did the transformation, what happened, how did this this graph change? Let's quickly analyze that now. So first thing first, the difference, the f at x as the 2 that is negative, and g at x as the 2 that is positive. So this tells me that on f at x, I need to take out negative as positive as a common factor. So this will be minus, then I'll be left with inside the bracket. Remember, my f at x, it's like saying this is negative, what? This is negative 2 over x plus 3, because this negative is like multiplying this, which will be this times that, which is minus 2. So I can take out that as a common factor, but now when I take it out as a common factor, I'll be left with 2 over x plus 3. Then look at this one. This one will be positive 1, because if I multiply out the bracket, I need to get f at x. So this will give me an f at x. So now I can see that, okay, so the difference now between this and that graph is that this one is x minus 1 and the other one is x plus 3. We are coming to that one next. So for the fact that the one is still, the one is positive, okay, let's not talk about that yet. So this graph is like saying I have minus f at x. So can you see that it changes from f into minus f at x. So to move from this to that, we need to multiply everything inside the bracket by negative, which is minus f at x. So we take the f at x, we multiply it by negative. So what is this telling you? What do you understand from that? Remember, we have x and y. Then this changes into what? Into x and minus y. So the y changes. So if the y changes the sign, this is reflection about what? This is the reflection about the x-axis. So if the x is the one changes, this will be the reflection about the y. So now the y is the one that changes the sign. So it's from positive y to minus y. So the reflection f is reflected about the x-axis. Right. So, and then what about the shift? What about the shift? So now, look at this. The one started by being negative 1. The one is negative 1, then it becomes positive. So remember, if it's positive, it's minus 1, then it becomes positive 1. This tells you that we shifted what? We shifted, what can we say about that? Or maybe we can just leave that leave that part because minus 1 plus 1, let's not talk about, let me explain this part here. The x plus 3 and the minus 1. How do we move from positive 3 to minus 1? Remember, we can shift if this is, I know that my positive 3 is here, my minus 1 is here. So I have 0, I have 1, I have 2. So how do I move from this to that? How do we move from that to, so this tells you that the graph is going to shift 4 units to what? 4 units to the right. Don't say to the left, né? Don't say to the left. If you say to the left, it's wrong. It's going to shift. The only thing I need you to understand is the units. How many? This is 1, 2, 3, 4. So it's going to be 4 units. So the graph shift 4 units to the right. How do we know that is to the right? You check the final answer. If the answer is negative, just know we went to the right. And if it's positive, just know that we went to the left. So this will be the graph shifted. It then shifted 4 units to the right. So now the reason I'm saying that, let's not focus on these two guys. Né? This, remember, gives us the up and down movement. Now you can just leave it like that. It just tells us the asymptote, which value your graph must not touch, something like that. Né? But now you can just leave that one and give them the left and right shift, and also the reflection if it's about the x and the y. And that's it for this question. This was the last one. Let's quickly move to the next one. On the next one, they say that we are given f at x, which is 2 times 3 to the power x plus 1. Write down the coordinates of the y-intercept. So to answer 6.1, we know that the y-intercept, how do we find the y-intercept? If x is 0, meaning that on my equation where there's x, I need to put 0. So this will be y is equals to 2 to the power 3 is 3 to the power 0 plus 1. So anything to the power 0 is 1. So this will give us 2 times 1, which is just 1. I'm not going to waste so much time because this is 1 mark. So this will be 2 times 1 plus 1 is 3. So now the x-intercept here will be 0 and 3. Next question, write down the equation of the asymptote of f. So the asymptote is this one there. So that is your y. Y is equal to 1. And then since x, we are not adding x there on top, we don't have that. So the asymptote is just, we focus on the horizontal asymptote because this is an exponential function. Y is equals to 1. Draw a sketch of the following, clearly showing the asymptote and the intercept. So let me quickly draw that graph. Let's draw the graph. This is my graph, and first thing first, you always start with the asymptote. Indicate your asymptote. So this will be my asymptote. Okay, the asymptote will be at what? Not minus 1, net. So this is where I'm going to put my asymptote. It's at y is equals to 1. That y is equals to 1. Then, and now let's talk about the shape of the graph. So if the value of b is greater than 1, your graph will look like this. Your graph, the shape of the graph will be like this. Right. And if the value of b is less than 1 and greater than 0, the shape of the graph will look like this. I hope you guys understand. So now we know that the value of b is that 3, which is because this thing is in the form of y is equal to a b to the power x plus q. So now the value of b is that, so we know that my graph will look like this because the value of b is greater than what? The value of b is greater than 1. Then this is my y-intercept, which we just calculated as 0 and 3. So this will be 0 and 3. Then when you have it like that, you're going to collect all the marks. Indicate that this is your f and this is your asymptote and give them the y-intercept. Then you are done. I think this was the easiest question. How many marks? Simple 8 marks. No? So write down the range. Look at this one. They want us to write down the range of h, if h at x. So what is h at x? H at x is equals to 2 into 3 to the power x plus 1 with minus 5. So now I know that on top the difference is that this time we have x plus 1. So please note that that x plus 1 is just like 1 unit. So it's 1 unit and it does not affect the range. So this one does not affect range. So since it does not affect range, we need to focus on the value of a. The value of a is positive, so our graph will look like this. But we know that b is what? B is greater than 1. This is the shape of the graph. So we're going to take the range. Our graph will take from the asymptote, but it must not touch the asymptote all the way up. But look at this. This time the asymptote is minus 5. So the range must be greater than minus 5. So it must take from minus 5 going up, but it must not touch that minus 5. Okay, I hope you guys understand how to answer this one. Let's see what we have on the next question. Okay, so now let's work on the next question. So we are done with question 6. Let's focus on question 7. Look at what we have on question 7. In the diagram below shows the graph of f at x. So f at x is a quadratic graph and we are given g at x to be mx plus q. So d has the point minus 1 and 4 and we have f that has 1 and 6 are points of intersection. So D and F are the points of intersection of these two graphs. T and U are the x-intercept. So E is the y-intercept of F and S is the x-intercept. So let's use this information to answer the following questions. Write down the axis of symmetry of F. Okay, so when they want you to write down the equation of symmetry of F, remember the equation of symmetry is the line that divides the graph into two equal parts. So now what I'm going to do, I'm going to check where I have points, because if I had the x-intercept of that, I was going to use the x-intercept to find the midpoint, because the axis of symmetry cuts what? The graph into two equal parts. But when I look at this is my point E and this is my point what? This is my point F. So look at the y coordinates of these 2 points. They are the same. So this tells you that we have a line here. Since they have the same y coordinates, we have a line here that is parallel to the x-axis. So we can use that line to find the midpoint of this graph. And when you find the midpoint, how do we find the midpoint? We're going to focus only on the x values. So this is 1 and this is 2. And the question said write it down, so we don't have to do any calculations. So now to find this, we're going to add how do we find the midpoint of a graph? Let's start there. So this will be 7.1. How do we find the midpoint? If you go back to paper 2, to find the midpoint, remember we take the value of the x1, we add that with the value of the x2. The answer that you get, you divide by 2. So this will be 1. We need to add that with 0, divide by 2. So this tells us that the axis of symmetry is just 1 over 2. 1 over 2. So it cuts somewhere here. So the midpoint here, it's 1 over 2. That 1 over 2 is your axis of symmetry. It's your axis of symmetry. I'm just going to put it there in the graph just in case we need that. So x is equals to 1 over 2. Please make sure that you give them that answer and say the axis of symmetry, it's x, it's equals to 1 over 2. And that's it for that one. For which values of x is f at x decreasing? Where is f at x decreasing? So now let me explain this, the concept of increasing and decreasing. So look at how the graph looks like. The graph is concave up. And if the graph is concave up, remember, you always move from left to right. You're going to move from left to right. So wherever you go up the slope, you are increasing. So this part here, you are increasing. Right, but what I need you to understand is that the concavity changes where? At the axis of symmetry, which is the x coordinate of the turning point. So this tells us that this x is also our turning point, this guy. So now the axis of symmetry changes exactly at x is equal to minus 2. Then you start going down. So when you go down, you are decreasing. So now this tells me that you are decreasing. Let's go to the graph. From this point, going in that direction, the graph is decreasing. So you are decreasing from this point, going in that direction. And remember, we know what is the x here. The x is 1 over 2. So you are decreasing from 1 over 2, going in that direction. So the answer is x must be greater than 1 over 2. I'm just going to put it here and say for 7.2, for which values of x it's f decreasing, x must be greater than 1 over 2. And that's it for that one. We can move to the next one. But before we do that, remember, someone might prefer to write the answer like this and say x must be an element of, it starts at 1 over 2. It goes all to infinity. Even if you do it like that, you are still correct. So let's look at what they want us to do on this 7.3. Calculate the average gradient. The average gradient, we know the formula that we use for the average gradient. So this will be my 7.3 of f between D and E. Let's indicate our graph. So this is D, this is point E. They want us to find the average gradient of those 2 points. So first thing first, I can write down my points and say D is minus 1 and 4. And then we have E, which is 0 and 6. Okay, so now when it's like this, let's name our point. This is x1, y1. This will be my x2, y2, because this is my second point. Okay, so now when we calculate the average gradient, I think you guys already know the formula. I'm not sure if there's a formula sheet at the back. There's no formula sheet. So now there's no formula sheet, so this tells you that you are on your own. You need to know the formula for gradient. So this has to do with paper 2. So now I think on this question they keep on asking paper 2 questions now. So the average gradient is going to be, I'm not sure if we are allowed to write the formula because this is paper 2, but let's just write the formula to be on the safe side. Remember the gradient of DE, we can calculate that by saying y2 minus y1 and everything divided by x2 minus x1. So the gradient of DE will be equal to, we know what is y2, it's 6. So this will be 6 minus y1, which is 4. So on top, we just have 2 divided by x2. x2 is 0 minus into, please, this x1 is negative. We need to put it inside the bracket. Then punch the calculator, find that your DE is equals to, on top I just have 2, on bottom I have 1. So the gradient the gradient is just 2, and that's it. The average gradient will be 2. Then when you have it like that for 7.3, you're going to have all the marks. It's a ding ding ding. Okay, so now on 7.4, determine the equation of G. The equation of G. So G is a straight line. So since G is a straight line, so this will be 7.4, the equation of G at X. So to find the equation of G at X, I need you to pause the lesson and try to find that equation and put it in the form of mx plus q. Okay, I hope you paused the lesson and you worked on this problem. Let's see if you got the same answer as the one that we're going to get when we go through this problem. First thing first, we need to have 2 points on that graph so that we can calculate the gradient of those 2 points. So now I know that I have F and D. I need to calculate the gradient of those 2 points. So now to find the gradient of that, I need to first find the gradient of, what is this? The gradient of df. So we use the formula y2 minus y1 over x2 minus x1. And remember, I don't want to make mistakes, so I'm just going to name my point. The first one is D. This will be my x1, this will be my y1, and this will be my x2, the 6 will be my y2. Let me do my substitution. What do I get when I substitute? So y2 is 6 minus y1, which is 4. Everything divided by x2, which is 1, minus x1, it's negative, put it inside the bracket. So the gradient of df, if you punch that on the calculator, on top you have 2, on bottom you have 2. So it's just 2 over 2, which is 1. So this tells me that my g at x, I can write my g at x in this form. Let's substitute the gradient on g at x. So g at x, it's equal to, where there's gradient we put 1, which will just give us x plus c. I'm sorry we used q. Let's use c instead. So this is plus c. So when I have it like this, I need to choose any point to find the value of c. You can substitute f or d, any point on that graph. So I'm going to sub in that f, which is 1 and 6. So on this one, which one is your x and which one is your y? So this is my x coordinate, this is my y, meaning on this graph, remember this is the same as saying y is equals to x plus c. Where there's y, we put 6, and where there's x, we're going to substitute our x as 1. So this will be, where there's y, I put 6, it's equal to, where there's x, we put 1 plus c. So the 1 will come to the other side to be negative. What is the value of c? It's just 5. So because c is 6 minus 1. So now that you have this, make sure that you substitute that back on the equation and say, from this equation, g at x, it's x plus 5. So this is the equation of that straight line. This is the equation of that straight line. Let's go to 7.5. 7.5 shows that f at x, it's equals to minus x squared plus x plus 6. And this is for 4 marks. So for now, we don't have any idea what we need to do. We don't have any idea. Let us quickly go back to our equation. Let's look at the equation. Then when I look at the graph, I look at this y-intercept. Always we know that the y value here is the value of c. So I can go back and substitute that on my equation. So let's write this down like this. Let's say I'm going to write this down like this and say this is my 7.5 problem. And then I know that f at x is a quadratic, so it will be in the form of ax squared plus bx plus c. What is the aim on this? Finding a, b, and c. So let's quickly work on that. You know what I'm going to do? I need to substitute something here because already I know this cuts my y-intercept at 6. So the value of c is 6. We don't have to stress about that. We can just substitute it. We can say c is equals to 6. Therefore, what is f at x equals to? So this will be ax squared plus bx, where the c I'm going to put positive 6. Right. Therefore, this is my f at x. Now, I can substitute any value on the equation. I can substitute d, I can substitute f. Let's substitute these two equations that are on the graph. Let me quickly highlight those points. Let's substitute this and let's substitute that point because these are any other points. I'm not going to use the x-intercept if it was given. I'm not going to use that one. I'm not going to use the y-intercept. I just need any given point, which is at those two ones. Let's start with d. So d is minus 1 and 4. I'm just going to write it down here. I have d, which is minus 1 and 4. So this is my x, this is my y. So where there's y, I can put 4. And where there's x, I can put that. And then we can work on this to create equation 1. So we're going to solve this simultaneously. So what I'm going to do, I know that this is y. So where there's y, we put 4. And where there's x, we need to put that minus 1. So this will be a into minus 1 squared plus b into minus 1 plus c. This is the same as saying 4 is equals to minus 1 squared is just 1. So this will be a minus b plus 6. Let's take maybe we can just make a subject of the formula from this equation. So the 6 comes this side to be 4 minus 6 and the b comes this side to be positive b. Everything is equals to a. So what is a equals to? So a is equals to 4 minus 6, that's minus 2 plus b. So this will be b. What is this equals to? B. A is b minus what? A is b minus 2. Let's call this one equation 1. So we are done with this d. We need to use another given point on the graph, which is f, to create another equation. So f is 1 and 6. So now I can substitute my f, which is 1 and 6. So remember where there's y, we put y, which is 6. It's equals to a into where there's x, we put 1. So this will be 1 squared plus b into 1. Then we add 6. So now we just have to work this thing out. This will be 6 is equals to a plus b plus c. So what happens when the 6 goes to the other side? We just get 6 minus 6, it's 0. So this will be 0 is equals to a plus b. Let's call this equation 2. But now we know what is the value of a is. We already have a. So a is equals to b minus 2, meaning that on this equation that we are currently working on, where there's a, we can put what? B minus 2. So we can say 0 is equals to, where there's a, I substitute all that. So this will be a is b minus 2. Then we add b. And then this was equated to 0. So now let's add the like terms. B plus b, that's 2b. So this will give us 0 is equals to 2b minus 2. So the 2 will go to this side to be positive. Therefore, what is the value of b when you divide? The value of b is just what? Is just 1. Before I get too much excited, I'll go back and verify on this equation if the value of b is 1. Yes, the value of b is 1 because this is in the form of ax squared plus bx plus c. Because b is the coefficient of what? Of x. So the value of x is indeed 1. So I'm happy about that. And the value of c, we can say it's 6. Now we need to find the value of a. Remember, from the equation a is equal to b minus 2. We can use that to find the value of a because now we know what is the value of b. take that and substitute there. This will be b, which is 1 minus 2. What is a? A is negative 1. So now this we've managed to prove that f at x is minus, the value of a is minus 1. So therefore you can substitute this on the final equation and say f at x is equals to minus x squared plus x plus 6. Then when you have it like this, everything is good. Right, I hope you guys are enjoying this. So let's go to 7.7. Let's see what we have on that 7.7 and what we need to find. So for which values of x, it's f at x minus g at x less than 0. Remember, the most important thing is for you to understand what is the question saying. What is the question saying? Okay, wait, this is 7.6. There's 7.6 there. 7.6, calculate the length of SU. And this is also 5 marks. So this tells us that we need to do work. The length of SU. Let's look at S. Where's S? Okay, the length of S, which is this one, the length of SU. So we need to find the length of that. So there's nothing we can do without finding our x-intercepts. There's nothing we can do. But when I look at this, if this is my g at x, S is the point of intersection. No. Look at this. It's not the point of intersection. S is the x-intercept of what? X. I'm just going to write this down. We are saying that S is the x-intercept of g at x. Okay? And we know what is the equation of g at x. G at x is equals to x plus 5. So it will be easy for us to find the coordinates of s. So let's work on that. So we can find the x-intercept if y is 0. This means that on g, where there's y, we put 0. So this will be 0. It's equals to, what is your x? It's x plus 5. So now the 5 goes to the other 5x, it's minus 5. So this tells me that S will have the coordinates 0 and minus 5. So let's write this coordinate down. This will be 0 and minus 5. Okay, everything is good now. We have S, but now we need to find U. To find the coordinates of U, U is the y-intercept of this f at x. So we need to take f at x, we need to take this one. I need to work on f at x. I'm very sorry guys, but I think it's not like, I'm very sorry about the space, né? But if you follow through, I don't think you're going to be confused, né? So then we are still working on 7.6. So what I'm going to do on 7.6, I'm going to say f at x is equals to negative x squared plus x plus 6. So we are looking for the x-intercept if y is 0. So where there's y, we can put 0 and say this is minus x squared plus x plus 6. Okay, so now we need to factorize this quadratic equation, but I know that most of you know that when we factorize the quadratic formula, the most important thing is to make sure that that value of a, we need to change minus x squared to be positive. How can we do that? Just multiply everything by what? By negative. So the sign of every term there will change. So this will be x squared minus x minus 6 is equal to 0. Then you can definitely factorize this. So when you factorize, I'll have x, and the factors of 6 that when we add or subtract, they give us a middle term of 1 is just 3 and 2. So since 6 is negative, this sign, the sign of the middle number we give it to the bigger number. So this one will be positive. This is equal to 0. So what is the value of x now? X is equal to 3, or x is equal to minus 2. So let's go back and look at u. You should have a positive what? You should have a positive x value. So this tells us that this is the x coordinate of u. So u, the coordinate of u will be, we already know that y is 0. This will be 3 and 0. So those are the coordinates of u, 3 and 0. So this is 3 and 0. So now the question said find the length from S to U. Remember the distance formula. So SU, to find the length from U, we have the coordinates of these 2 points. So the distance of SU is equals to, I always start, we take the 1 on the left hand side, which is 3. Then you're going to say this will be 3. Then you need to minus the 1 that is on the left. We need to minus because we are trying to find the distance. But this one, we're going to say 3. We minus, I think we made a mistake here when we write this, because now it doesn't make sense when we say x is 0. X is not 0 now. We did vice versa. X is minus 5. I hope you guys did see that now. Because now I see that how can this, because I see that if I minus 0, it only gives me from this point going that side. But what about the other side? So that's when I realized that no, there is a mistake somewhere. So this is minus 5 and 0. This is minus 5 and 0. So now this will be 3 minus into minus 5. So the distance will be 8 units. And that's it. This is the answer for 7.6. I hope you guys understand what we did then. So let's move to the next one. Let's see what we need to do on the next question. 7.7. So now on 7.7, this 7.7, they say determine the values of x for which f at x minus g at x is less than 0. You know, let me talk about the best way to do this now. The best way is to first understand what is the question saying. So f at x minus g at x is less than 0. So it's like saying the y is less than g at x. So when we subtract these two, we get a negative answer. Look at this. Y, it's a small number. We minus g, which is a big number, and we get an answer that is negative. So they are trying to ask you where it's f at x below g at x. So when you subtract the two numbers and your answer is negative, they are asking you where it's f at x below. Because if they said f at x minus g at x greater than or equals to 0, they are asking you where it's f at x above. Look at what you are subtracting from. Then you interpret from that. So when they say f at x minus g at x greater or equals to 0, they are asking you where it's f at x above g at x. But when you subtract the 2, because now when you subtract the 2, remember this, if we subtract this one, this tells you that f is the bigger number. We are subtracting the small number and we get what? A positive number greater or equals to 0. Guys, I hope you understand this, but let's go and do this on the board properly. So we are saying that they are asking where it's f at x minus g at x less than or equal to 0. So now we say that you take a small number, you subtract a bigger number, we're going to get an answer as negative. So this tells you that where is f at x below g at x. Why? Because we got a negative answer. So the negative answer is the one that is telling you, you say the first one, where is the first one? The negative tells us that it's below. First one, negative, below. Then if they ask it like this in an exam, let's say they decide to change the question and say where is f at x minus g at x greater or equals to 0. They are asking where is f at x, which is the bigger number, minus g at x, which is the small number, and this gives us positive. So remember, we say this one is going to be where is f at x above the positive. For the fact that we got positive, this tells us that whatever that we are subtracting for is positive, which makes it to be above. So this one, f at x, positive, above. So where is f at x above g at x? But now, for this question, this is what we need to focus on. Where is f at x below g at x? Let's go on the graph and indicate that. So when you answer this type of question, number one, first look on the point of intersection. Where the two graphs meet, then indicate those graphs at those points, 1, 2. So these are my point of intersection. Then remember, this is f at x, and if this is f at x, we need where f at x is below. So f at x is below g at x from this point going down. Can you see that the more we go down, the more it's f at x below? And then it's also below g at x from this point going down. So this tells you that our answer should be from this point going in that direction, and from this point going in that direction. So we just need the x values. I hope you guys understand this part. Remember, the x value of that f is 1. So we are saying from this point going in that direction, and from this point going in that direction, guys. So now our answer should be x, this side. What is x? On that one, x must be greater than, and I'll go check if the equal sign was included. So it's less than or equal to, so x must be greater or equal to that x coordinate at that point of intersection, which is 1. So for this one here, x, because we go in that direction, it's less than or equals to that x coordinate, which is minus 1. And this question is answered. So the question for this one, it's x must be greater or equals to 1, and then x must be less than or equals to minus 1. Then that is your answer. Please make sure that if you don't understand this part, try to work on it again. Move back on the lesson and then try to work on it again, step by step. But I don't even mind if we can just go through it again on the whiteboard. Remember, we have f at x. Okay. Let's write down our f at x. This was my f at x, and oh no, this is not good. Okay, let's write it down. I had my f at x like this, and then we had like g at x like that. So let's write down the coordinates of the point of intersection. This was f, which had the point 1 and 6, and this was d, which had the point minus 1. Let me quickly go check. It was minus 1 and 4. So this d, it's minus 1 and 4. The question says where is f at x minus g at x less than or equal to 0. That's what the question was saying. And we said to answer this, we look at the point of intersection, because they are asking where is f at x below g at x, because when you subtract these two, you get your answer as negative. So we said that it's from this point here, where it's f at x below, from that point going down. Why it's f at x below g at x, from this point going down. Can you see that there's g at x, it's above. There's g at x, it's above. So you can see that there f at x is below. So which point are we looking for? From this point going in that direction. So so x must be greater than or equals to what? That x coordinate of the point of intersection is 1. And this side, we are looking from this point going in that direction. So this will be x must be less than or equal to that minus 1. So the answer is that. So answer is x must be less than or equal to minus 1, or x must be greater or equal to 1. I hope you guys understand this one. Okay, let's look at what we have on the next question. The next question says, let's see, 7.8. 7.8. Calculate the maximum length of VW. Calculate the maximum length of VW. Let's go and see where's VW next. So this is my VW. I'm just gonna try and make some space there so that when we put our information, we're going to be on the same page. So now I have VW, which is the length from this point to that point. So when they wanted the distance of VW, look at where is V. V is on f at x. It's a point on there. It touches f at x, and then W, it touches g at x. So what I need you to remember is that to find the length of a vertical distance, so let's go back to the question. Calculate the maximum length of VW. Okay, the maximum length. So to find that, you know what we're going to do? We need to find the length, and to do that, we're going to say which one is on top. It's V. We need to take the y of the V of the one that is on top, the y coordinate of V. So the y coordinate of V, remember this will be x and y of V. We take the y of V, we subtract the y coordinate, this is x of W and y of W. Then we substitute the y of W. The answer that we get, will take it from there. So you just have to find the difference. So now to find that to find the corresponding y value, I'll definitely explain, guys, what you need to do. You're going to say what you're going to do first. You can just find, let's find the one on top is my f at x, then we subtract the one on bottom, which is my g at x. Then when you do that, we're going to get the corresponding y value. And then remember, to find the corresponding y value, we can substitute f at x and then subtract that with what? Then let's subtract that with g at x. So we can use this to find the x coordinate of these numbers. Look at this. You can see that these two going to have the same x coordinate. Why? Because the VW is a vertical line. Let's quickly work on that on the board. So we are saying that we first need to find f at x minus g at x. I hope you guys still remember what is our f at x and what is our g at x. So my f at x, this is equals to, it was minus x squared plus x plus 6, and my g at x, which is the straight line, we just calculated that to be x plus 5. And we are saying that to find the length, we're going to say this is y. Don't worry, guys, I'll teach you something here. Is going to be yv with minus y of w. And v is the one that is on f at x. So we're going to take f at x, we subtract g at x. So what is my f at x? It's minus x squared plus x plus 6. We need to subtract whatever that you are subtracting, which is g at x. Make sure that you put it inside the bracket. Okay, so let's multiply out the bracket with that negative and see what we get. So this is minus x minus 5, and then let's work on this. So this will be minus x squared minus x, and this cancels, and 6 minus 5 is just positive 1. So this is what we get. So now, to find the maximum length, there are many ways that you can try and work on this. You can also consider maybe finding the derivative, but I'm just going to show you guys the easy way. So what I can do on this one, I can find the x. I can find the value of x, or I can just look at my y coordinate of these two graphs. Look at this. This is the value of, if we look at this, this is the value of what? This is the value of c on your graph. This is the value of c. So what I can say is that by looking at this graph, there's no further calculations that we can do, but our max length of VW is that one. So the max length of VW is equals to what? It's equals to that one. But you can also try to verify this by doing more steps. How many marks? This is just 3 marks. So I think it's the best if we just do it like this. So the length of VW is just 1. I hope this is the last question for this paper. Yes, that was the last one. Let's go and work on the next one, which has to do with finance. Okay, let's look at the finance question. What do we have on this finance question? So on this one, the first question says that, question 8, the first question says, calculate the effective interest rate per annum if an investment and an interest rate of what? 9.3% compounded monthly. So what is my interest rate? So now what I'm going to do, they want us to calculate the I effective. You're going to write for this 8.1, you're going to write your formula down and say the I effective, we add 1, this is equals to 1 plus the I norm, and then divide this by m, everything to the power m. Right, so now when I have it like this, I just have to substitute. Remember, I have the I norm, which is 9.3. I first have to convert that I norm and say this will be equals to 9.3 divided by 100. So it's going to be 9.3, divide that guy by 100, and then the answer that you get, which is 0.093. So this will be 0.093. Remember, this is compounded monthly. We need to divide that by what? We need to divide that by 12, then solve for I effective. So I'm going to say, from this, I can write this thing. Maybe we should just take this on the other side. Né? Okay, so let's write what we have this side. We are given the I norm. The formula that we use is I effective, we add 1, and this is equated to what? 1 plus the I norm over m, and this is to the power m. So now I know that the interest is given as 9.3, which we need to divide by 100. So this will be 9.3 over 100. This gives us 0.093. So when we substitute the I effective plus 1, it's equals to 1 plus the I norm, which is 0.093, divided by m is the compounded. They said it's compounded monthly, and then to the power, they said it's compounded monthly. So this will be to the power m. To make, I think this is 3 marks now. To make the I effective subject of the formula, you can move the 1 to the other side. So this will be I effective, it's equals to 1 plus 0.093 over 12 to the power 12 minus 1. Then you just have to punch this on the calculator to get your I effective. So this was 8.1. You have to punch that on the calculator. Let's see what we get. So when we put this on the calculator, we get our answer to be 0.09707. Right, this is what? This is the I, and we are looking for the rate. Ne? So the rate, remember how do we convert this? We divide it by 100. So this tells you that to go back, we need to multiply that by 100. You need to multiply by 100. The answer that you get is your I effective. So this is just 9.71 if we round off this 7 here. So it's 9.71%, and this is the answer that they are looking for. Let's look at the next question. A school, they buy what? A school buys a bus that costs 312,000. So the 312,000, we know that is the money that we start with, is the original amount. So this is P. So P is equal to 312,000. We can see that at the start of 2023, the average inflation, guys, what is an inflation? Is the rate at which everything increases each year. So the average inflation over the next 5 years is 6.9. So this tells you that if you buy the bus today with 312,000, so after 5 years the bus is going to cost 3.91% more of 312,000. So they want us to calculate the cost of replacing the bus at the end of the 5 years. So we know that before that it was 312, and then we need to calculate the cost of that bus at the end of the next 5 years. And this is compound interest. We just use the formula. A is equals to P into 1 plus I to the power n. So now n is equals to 5, and then the interest rate is just our I will be the 6.91, divide that by 100, and I is equal to, let's quickly punch that on the calculator. So this gives us 0.0691. So it's 0.0691. So when you do your substitution, the cost of the bus after 5 years, A will be equals to, where there's P, I put the principal amount into 1 plus the interest rate. The interest rate is 0.09691 to the power 5. Then when you punch this on the calculator, you should have the final answer. So this is how you solve this problem. And how many marks? This was just 2 marks, ne? Is it 2 marks? 3 marks. This was just 3 marks. So let's quickly put this. I get on my side 435,000. So the cost of the car will be 435,758. Listen carefully. And then now this is 88. Okay, so that's the amount. Now this was easy, 3 marks. So let's look at what we need to do. Do we have enough space? Yes. So 8.3.1, let's read the statement for 8.3. We are given that Rwandi made an initial deposit of what? Of 23,000 into an investment account that paid an interest rate of 9.2%, compounded quarterly. You see, I underlined the most important words. After 3 years, since the start of his investment, he deposited what? Another 13,500. And now the interest rate changed to 8.2%. I think now these questions start to be like they are giving me a lot of information on the statement. So to make this easy, I'm going to draw a number line. So on my number line, we start at T0. This is where this guy deposit what? This is where the guy deposit 23,000. So at T0, we have 23,000 that is deposited. So I'm just gonna say we have plus 23,000. At T0, we add 23,000. Right, that is what we know from that. And then now if this is T0, let's just do a very big number line. Right, so if this is T0, what I know is that after T0 there's T1, there's T2, and there's T3. So this is my T3. So now what are they saying on T3? Let's go back. T3 is year number 3. They said that after 3 years, since the start of his investment, he deposit what? Another 13,500. So this tells us that at T3, we add 13,500. Right. So now, what I need you to understand is that between these two interval, T1 and T3, what was the interest rate? What was the interest rate between those two? Let's go back. They said the interest rate is 9.25% and it's compounded quarterly. So I'm just going to put it down here so that I don't forget. This is 9.25%, which is compounded quarterly. Okay, let's move and continue with the statement. They say that after 3 years since he start the investment, okay, we're done with that one. The interest rate after depositing what? After this person deposit 13,500, the interest rate it changes to 8.2% per annum, compounded monthly. So exactly 5 years after his initial deposit, Lwandi withdraw 9,000. So let's go to T number 5. So we need to put T number 5 on the number line. So this will be my T4 and this will be my T5. So at T5, this guy takes out, subtract 9,000 rand. At T5, this guy subtract 9,000 rand. But now remember, after he made the initial deposit of what? Not the initial deposit. After he made the deposit of 13,500, what happened then? What was the interest rate between this interval? The interest rate changes to 8.2 per annum. It's 8.2%, but it was compounded what? Compounded monthly. So this will be compounded monthly. So I think if we draw the number line, this is the best way for you to understand the situation. So this will be compounded monthly. So now this tells you that T0 we add 23,000, and then at T3 we add another money which is 13,500. But the interval between T0 and T3 has the interest of 9.25. That's what the statement is saying. Then immediately after this guy deposit 13,500, the interest rate changed. So from T3 to T5, this guy has an interest rate of what? It has an interest rate of 8.2. So that is the statement. That is what is the statement saying. Let's try to answer the following question. 8.3.1. Calculate the total value of Lwandi's account at the end of the 5 year. They want us to calculate the interest at the end of the 5 year. So this is what I'm going to do. I need to calculate this for that 5 year. So at the end of the 5 year, remember at the end of the 5 year, this is where this guy withdraw 9,000. But now we need to calculate before the 9,000 was out. Okay, let's quickly calculate that. This is 8.3.1. So the formula that I'll go with, I know that this is compound interest, and I'm not sure how I can write this formula down, but please, let's just follow this step by step now. So the formula that we use is, this is compound, so we're going to say A is equals to P into 1 plus I. So that's the formula, A into P1 plus I, and this is to the power n. Okay, to the power n. So now, when I have this formula, you know what I'm going to do? I'm just going to remove this, because I think if I put it on this side, this one gives us enough space to have to write on it. So let's rewrite this here. Then we'll take it step by step. So for 8.3.1, A is equals to P into 1 plus I to the power n. But now let's try to analyze what is going on this question. What is going on this question? So I'm not going to use the snowball, but let's take it everything. Let's substitute everything on one, everything here. So the accumulated amount will be, listen very careful now. We start with, and I'm just going to open big bracket. We start with what? With 23,000. So this will be, is this 23,000 or 2,000? Okay. When it's like that, that's 23,000. Yeah? So we start with 23,000 rands. Right? Into 1 plus, look at the number line. We have 9.95, which is the interest rate. So the interest rate, you take that 9.25, you divide by 100. Don't substitute it as 9.25. You convert it first. So this will be 9.25. You divide that by 100, which gives us 0.0925. 0.0925. Then divide that by quarterly. This is compounded quarterly. Quarterly it's 4. So let's also include that. The quarterly is 4. Then close the bracket. What is your n? This is for how many years? This is for how many years? So now, look at this. Don't make a mistake. They said for 5 years. Yes, we know it was for 5 years. But this 23,000 had the interest rate of 9.25 for 3 years. So for 3 years, that is compounded quarterly. So n will be 3 times 4. I hope you guys understand that one. So if it is compounded quarterly, the number of years, you multiply that by 4. Okay. Then after, we have what? We have the 13,500 that was deposited into the account. So I'm going to add this here. We add the 13,500. So before we do anything, let me explain what is going on here on my formula. I'm very sorry. So this is what is going on. So on this question, we first start with 23,000. We leave that guy for 3 years, and it creates an interest. So after getting an interest, we add 13,500 on top of that interest. We first have to calculate how much we have at T3 before the interest rate changes. I hope you guys are happy with that. So A is equals to, I'm going to punch this on the calculator and see what I get. Okay, so when I put this on the calculator, this gives me 23,000 into 1 plus 0.295 over 4, and everything to the power 3 times 4, which is 12 plus 30. So this gives me 51,530, and if we round this off, it's 1.8. Okay, it's 1.8. No. I made a mistake. Let me fix my mistake there. Okay, so when I punch this on the calculator, you know what, guys? Let's just work on this one. Let me explain something here. Let me explain something here. So let's say that this is, instead of punching this on the calculator, I think that we're going to cause more confusion. You see, this amount that we get here is the amount after 3 years. Let's take that amount and invest it for the next 2 years, because it's from 3 to T5. Let's invest that for the next 2 years with that interest rate of 8.2. So I think if we do our calculations like that, it will be more easy for us to find the correct answer. So we're going to take whatever that we get inside the big bracket, we're going to multiply that by 1 plus, because we need to understand how much interest that money will make. So this will be 8.2, which is 0.082, divide by, this one is compounded monthly. So since it's compounded monthly, we divide by 12, and will be, monthly is 12, and we leave this money for 2 years. So it's going to be 2 times 12. I think now we can punch the calculator to know the amount that this guy will have after 5 years. So now when I punch this on the calculator, I'll just take the answer that I got on my calculator and multiply that by 1 plus 0.082 divided by 12 to the power 2 times 2. And this gives me 51,530, and if I round it off, it's 18. Now this is where I realized that if I go round, this is going to cause more confusion. It's best if we just go straight to the point. So now let's go back and understand what is the question saying. Calculate the total value of the investment in Lwandi's account at the end of 5 years. So remember, this guy, after 5 years, this guy withdraw 9,000. So we need to remove that 9,000 from this amount. We need to remove the 9,000. The amount that you get is the money that this guy will have at the end of 5 years. So this will be 51,530.18 divide minus 9,000. So this guy will have 42,760.23. So this is the amount he will get after 5 years. Right, and that's it for this question. Let's see what we have on the next question. Okay, so now they say that at the end of 8 years, after the initial deposit, Lwandi decide to withdraw and use the money. So so this tells you that what will Lwandi do? Lwandi is going to leave the money for 8 years, and then after 8 years withdraw. So they say calculate the annual interest rate of the investment in the final 3 years. So now on our timetable timeline, we'll have T6, T7, and T8. So we need to know what is T8 now. From this part to that part, N is 3. Right, so N is 3, and then now we need to find the interest rate on that block. What is the interest rate? We need to find that. Calculate the annual interest rate of the investment in the final 3 years. If the final balance, this is my balance, my A was 64,487, and the interest was compounded monthly. The interest was compounded monthly. Let's work on that and see what we get. So now to answer this 8.3.2, we're going to say that this is a compound. So A will be P into 1 plus I to the power N. And then let's substitute. The final amount is given as 64,487.24. So I'm just going to substitute that 64,487.24 is equals to the principal amount, the amount that we start with at T5. At T5, we start with this amount. This is the amount at T5 because we need to find what? The interest rate in that interval. The interest rate in that interval. So now, what I'm going to do is that I have to substitute my P as 42,760.23. Okay, was this 42,000? Let's go back and substitute this. Let's see, because this is not making sense, guys. When you make mistake, you know how you see if you are making a mistake. Look at this number, it's 0.18, but now when I minus this, I have 0.3 as a my cents 0.3. That's impossible. So this tells you that I did not punch the calculator correctly. So now I remember that it was 0.18, but now I have the cents as 23. This tells me that I've made a mistake. Now, so let me quickly work on that and try to punch this correctly on the calculator. Okay, so 51,530.18 minus 900. So when I put this on the calculator, I get the 42 was right, but the cents, nope. So this will be the correct answer. It's 42 530.18. 530.18. That was the correct answer. So now remember, we need to also fix this part. So this will be 42 530.18 into 1 plus the interest rate. It's what we are looking for. But what I need you to remember is that the interest rate is compounded monthly. Compounded monthly means divide that interest rate. We need to divide I by 12, and this is to the power. This was for 3 years. So it's going to be 3 times 12 on top. 3 times 12. We multiply the number of years by that 12. So now the aim is to isolate the value of I. So to do that, I can just divide both sides. Divide this side by 42,530.18. Divide the other side by 42,530.18. So these two cancels, and I'm left with, let's see what we have there. We are left with 64. Let's divide this to 64,487.24. Let's verify that. Is that what we got? Is that 64,487.24? Okay, and then we divide that by 42530.18. So this 2 gives us something like 1.55555. Please don't round it off. You just have to write it as 1.516 and so on, which is equals to 1 plus I over 12. Divide this by 3 times 12, which is 36. So I think you guys understand how we can remove 36 so that we can make I subject of the formula. So to remove 36, I can find the root of 36 on both sides. So this will be 36, the root of that on both sides, the root of that answer. So now this 36 will cancel that, and this side we are just left with 1 plus I. We are left with 1 plus I over 12, which is equals to 36, the root of that 1.516 and everything. So I'm going to first I can multiply everything by 12, it's fine, or I can just subtract 1 on both sides first. So what I'm trying to say, I can write this and say this will be, take the 1 to the other side, because you see I avoid rounding off. Take the 1.516 dot dot dot, then sub on this. Remember the 1 is not inside the bracket, né? So no need for me to include that. We're going to subtract 1, and then this guy will be equals to I over 12. So now we can multiply by 12 on both sides to find R. So you're going to take that 36, the root of that 36, 1.516, so all minus 1. You take this, you multiply that by 12. The answer that you get is your interest rate. So now remember, on my calculator, I still have this guy. I still have this on my calculator. I'm not going to erase it, because here I'm going to say the root of answer minus 1, everything inside the bracket, times 12. Please, the root of answer. You say the root of answer. So when I punch that, I get my I is equal to, let me quickly work on that. Okay, so when I punch this on the calculator, I get my answer to be 0.135, 135, okay, it's 135, 1395, 1395. So this will be 0.1395. And then, and those dots, and then now I is equal to multiply that by 100. We get our interest to be 13.96%. Please make sure that you go back and try to work on this step by step, okay? And that's it for this question. Let's move to question 9. There's still two more questions left. So we're not gonna waste too much time on this question 9. Let's see what we have on this one. So question 9, they said that for any two events A and B, it's given that the probability of what? The probability of A is 0.35 and the probability of A or B is 0.61. Determine the probability of B if A and B are mutually exclusive. So when we say the probability are mutually exclusive, what comes in your mind? The word mutually exclusive, what is that telling you? So now, the word mutually exclusive, this tells you that the intersection between the two probabilities, the probability of A and B is 0. There's no intersection. So this is telling us that the probability of A intersecting with B, this is just 0. The mutually exclusive definitely is saying that. So now to calculate the probability of A and B, what I know is that the probability of A or B, I can write this as the probability of A or B, this is equal to the sum of the two probabilities. Then you need to minus their intersection. But now we know the intersection is 0. Let's substitute what we have. The probability of A or B is 0.61. Let's equate this to the probability of A, which is 0.35, plus the probability of B minus the probability of the intersection. If A and B are mutually exclusive, their intersection is 0. So this tells us that we minus 0. Now we only have B. We can take the 0.35 to the other side. We can say this is the 0.61 minus 0.35. It's equal to what? The probability of B. Therefore, when you minus these two, you're going to have the probability of B. Okay, so when I put this on the calculator, 0.61 minus 0.35, I get the probability of B to be 0.26. This is the probability of B if A and B are mutually exclusive. So, but looking at the space, we don't have much space. I'm not sure the bottom will use it for question 10. I think now we can move to answer this one, let's move to the blackboard. But now let's talk about A and B. So they say that for A and B are independent. If A and B are independent, what comes in your mind is that the probability of A and B is equals to the probability of A multiplied by, let's use a different marker so that this doesn't cause any confusion. When two events are mutually exclusive, their intersection is 0. But when two events are independent, when you their probability is A multiplied by B. That is the probability. So now let me go to the board. Let's work on this. We're just gonna first write down what we are given. We were given the probability of A or B, and this was equals to 0.61. Right, and then we have the probability of, we were given the probability of A, and this was 0.35. And remember, we just calculated the that was when the two events was mutually exclusive. So what else do we have here? This was the information that was given, the probability of A or B, and we need to find B, the probability of B if A and B are independent. Right, so if A and B are independent, what are we going to do to work on that? So you know, we just said that. We said for A and B to be independent, the probability of the intersection is equal to P A multiplied by P of B. So let's write down our formula. We know that the probability of A or B the probability of A or B. So the probability of A or B is equals to the probability, the sum of the two probabilities, then we minus the intersection. So what do you get when you substitute? So when I substitute this is given, okay? But now what about this? We know that the intersection is equal to that. So I can rewrite my equation and say A or B is equal to the probability of A plus the probability of B minus the probability of A times the probability of B, meaning that A and B are independent. So we just substitute this with that, and then now we can substitute the probability of A or B is 0.61. Equate this to the probability of A, which was given as 0.35, and we are looking for what? That probability of B, minus the probability of A, we know it's 0.35. So this will be 0.35, the probability of B. Let's calculate the probability of B. So now, remember that the probability of B has the coefficient of 1. This is just 1, the probability of B, and for this one the coefficient of that one is 0.35. So this will be 1 minus 0.35, and then I need to take the 0.35 to the other side and subtract that from 0.61. So what I'm trying to say, this will be 0.61, we subtract the 0.35 because this will go to the other side and it changes. We equate this to what? We equate this to the probability of B minus 0.35, the probability of B. These are the like terms. We just add these two. This one are also the like terms. So this one, we know that this is 0.26 from the previous question that we worked on. You can also verify that on your calculator. So the probability of, if we say 1 minus 0.35, this gives us 0.65. So this will be 0.65, the probability of B. Now the aim is to find what? The probability of B. Can divide both sides by 0.65, 0.65. The answer that you get is the probability of B if A and B are independent events. 0.26 divided by 0.65, and this gives me an answer of 0.4. So this is the probability of B. And that's it for this question. Let's work on the next one. Okay. A cell phone distribution company investigated the number of defective phones that they obtained from two suppliers, Axis Phone and Direct Phones. They record their findings in the contingency table. Right, determine the values of A, B, and C. Look at this. I have 384, and I can first start by finding C. Né? So, if I take the 384, if we take that 3, let's first find C. If we take 384, we add that to C. This must give us a total of 600. So this must be equal to 600. Therefore, what is C? C is equal to the 384 goes to the other side, and this will be 600 minus 384. Then what is C? So quickly punch that on the calculator. Let's see what we get. So the value of C is 216. That's C. So this is 216. That's the value of C. So now that I have the value of C, it's going to be easy for me to find A. Because if I take A, I add A with 188. This must give me a total of what? A total of 216. So I'm working on this row now. I'm working on this row going down. If I take A and we add that with 188, we're going to get the value of A. So A will be equals to 216. We're going to minus that 188. Right. So the value of A, we say 216 minus 188. This gives us 86. The value of A to be 28, sorry. So the value of 8, let me also just verify this on my site. Because 2216 minus 188, this gives us 28. So the value of A is 28. Is it 3 marks, ne? So this will be 28. Right, the last one is finding the value of B. So if I take this 58, I add that with 28, I'll get the total, which is B. So what I'm trying to say is 58 plus A, which is 28, this should give me B. Therefore, B is equal to, we add these two terms, 28 plus 58, this gives us B to be 86. So this is 86. I'm just going to write it down there. This is 86. And that's it. This is how you find the values of A, the values of B and C. Let's answer the following question. Calculate the probability that a cell phone, chosen at random is supplied by a direct phones. So now I'll only focus on the direct phones row. Let's focus on that. So now I need the total. I need to know, to find the probability that a phone chosen at random is a direct phone. I need to find the total number of direct phones. Okay, the total number of direct phones. So this will be the probability that a cell phone, C for cell phone, and is direct. It's equal to the total number of direct phones, which is 216, divide that by the total number of all the phones, which is 600. Then this is my probability that I can simplify into 0.36. So that's how you collect that 1 mark. That was easy one. 9.2.3, Calculate the probability that a cell phone chosen at random is not defective, or it is from X's phone and defective. So these are two probabilities that I need to add. I need to add two probabilities. First thing first, let's first find the probability that a phone, a cell phone, and let's say the cell phone is what? The cell phone is not defective. Then we're going to add that with the probability that it's from the X's phone, which is AP, and it's defective. Let's work on that. So we need to add these two probabilities. Not defective, I'm going to focus on the row for defective, not defective. So this is the row that I'm referring to. I need to focus on that row. I need the total of the phones that are not defective. Oh, the total phones for the ones that are not defective, and the total is 514. So we have 514 phones that are not defective all over 600 phones. Then we added this with the probability that is from X's phone and defective. X's phones and defective. So you move that side, you move this side where these two arrows, that is the probability. So this will be 58 over 600. You just have to add those two and say what is the probability when you add the two. The 600 are the same. You can write as one denominator and add the top part. So this will be plus 58. Then on top we get 572 over 600. And what is this equals to in decimal form? That's 0.95. I think this is the easiest probability question I've ever seen. Guys, it's a ding ding ding. Now we do the last question. Wow, I'm so happy. I'm so happy that we're going to work on the last question, which is only one question and it has 4 marks. Let's work on that step by step. A bag contains X balls, of which 5 are red. Okay, we have number of balls. It's X. And then we have red, number of red, which are 5. Red is equal to 5 and the rest are green. So I think the rest are green. It's something that we don't have to forget now. So we only have 5 balls and the rest are green, but we don't know how many number of balls are inside that bag. So one ball is taken out of the bag randomly and it is not replaced. So I'm going to underline that, not replaced, because it is not, it's without replacement. You're going to see how this affects your probability. So a second ball is taken out of the bag, and then the probability picking both green is 3 over 11. Shows that the probability of picking both greens can be represented by what? Can be represented by that equation. I don't want to waste too much time on this. When I see this type of problem, I'll just go straight to a tree diagram, because I'm going to draw a ball, but there's a probability that it's a red one or a green one. So this will be my first event. So my first event, it's either I'm going to have a red one or we're going to have a green one. And then my second event, it's either that if the first event was red, there's a probability that the second one will also be red, or if the first one was red, there's another probability that the second one is green. If the first one was green, there's a probability that the first one is red, or there's a probability that the second one is green. Let's first write the probabilities of this. Now, we are not yet on the question. I just have to create my tree diagram before I can answer this question. So they said that let's find the probability that the first ball was red. The probability that the first ball was red. So what I'm going to do, how many red do we have? We said there are 5. So 5 all over the total number of balls, which is x. So this will be 5 over x. And now, what is the probability that the first one was green? Remember, we don't know the number of greens, but we know that if we have red 5, the rest is green. So we can say that from the number of balls, if we subtract the red ones, we're going to have the total number of green and divide that by our total number of balls. I hope you guys understand that part. So let's move to this one. What is the probability that if the first one was red, what is the probability that the second one is also red? So remember, we are taking without replacement. We are taking without replacement. So this tells you that if the first event was red, how many red balls do we have? If the first event we take red, we only left with 4. Over. So now since we left with 4, the number of balls, we no longer have x, but we need to subtract that red that we drawn on our first event. So this will be x minus 1. Then let's do the same. If the first event was red, what is the probability that the second event is green? So now, if the first event is red, we need to subtract, right? If the first event is red, we need to find the total number of greens that we have, because the total number of greens will still remain the same, because the second event depends on what we did on the first event. So the first event we pick up red. This tells you that the number of greens are still x minus 5 over the total number of balls. Now, the total number of balls will still remain x minus 1, which is the red that we picked on the first event. I hope you guys are following on this one. So let's move to the next one. Let's assume that the first event, we picked green. What is the probability that the second event we pick red? So look at this. The probability that the second one is red. How many red do we have if the first one was green? We still have 5 of them because there are 5 red. So the first event we did not take any red, so there are still 5. Then this will be over. Then we're going to say from the green balls we subtract 1 green from all the total balls we subtract that one that we drawn on the first event. Okay, if we do this, let's say what is the probability that the first one was green? If the first one was green, what is the probability that the second one is also green? So now look at this. The first one was green, right? The first one was green. And what is the probability that the second one is also green? So if we pick the green, we need to do what? We need to say from x, right? We don't know how many number of greens we have. We're going to say x minus the total number of greens, because we need the total number of greens, and then we subtract that 1 green that we took on the first one. So now to find the total number of greens, we're going to subtract 5, which is red. We subtract 5. So if we say x minus 5, we're going to get the total number of greens that we have. But remember, we also drawn green on the first event, so we need to minus 1 there and divide this by what? The total number of the balls, which is x minus the one that we took on the first event. So this here, the probability will be x minus 6 over x minus 1. Right, let's go to the question now. The question says that the probability of picking both green is 3 over 11. The probability of picking both green is 3 over 11. So what they are saying is that the probability that we pick green and green is going to be equals to, it's given as what? It's given as 11 over 3 over 11. So now remember, the probability that the first event is green and the second event is green, we need to multiply these two probabilities. So the probability that both of them are green, it will be the probability of the first one being green, multiply that by the probability of the second one being green. Let's equate this to 3 over 11. So the probability that the first one is green, it's x minus 5 over x. Multiply that, the probability that the second one is green, it's x minus 6 over x minus 1. And this is equal to 3 over 11. So now we just have to solve this, and the answer that we get is that one. Then I'm going to be very happy and end the lesson. So now we row multiply. We're going to row multiply. When we say row multiply, the top part will be x minus 5 multiplied by x minus 6, and the bottom part is x into x minus 1, which is equated to 3 over 11. Let's multiply out the brackets on top. This will give me the top part. I think it's best if we say the top part is what? Is going to be x squared minus 6x minus 5x. That gives me minus 11x. Then minus 5 times minus 6 is positive 30. And the bottom part, I have this as x squared into, it's x squared minus x, and this is equated to what? 3 over 11. Okay, so now I think we just have to cross multiply this equation. The top part, everything on top, we need to multiply it by 11, and everything on top we need to multiply it by 3. So this times that, this times that, everything. So I'm just going to put this guy here and say 11 will multiply everything on top, which is x squared minus 11x plus 30. This will be equated to the 3 will multiply everything on bottom, x squared minus x. Then let's work this out. Multiply the bracket by 11. This is 11x squared. Then 11 times minus 11, that's minus 121 x. Then 11 times 30, that's 330. Let's equate this to 3 times 3x squared, that's 3x squared. 3 times minus x, that's minus 3x. So I'm just going to move everything this side so that I can add the like terms. 11x squared. We're going to subtract 3x squared there. Then minus 121x. We're going to add 3x. Then we add the 330. Then this is equated to 0. So these two guys gives us 8x squared. And then minus 121 plus 3x, this gives us minus negative 118x plus 330 is equal to 0. So now let's see what the question said. They said this should be 4x squared minus 59x plus 165. So look at this. How can I get 4x from that? I can just divide this by what? By 2. And divide that by 2, divide that by 2, divide that by 2. Everything by 2. then this gives me 4x squared minus 118 divided by 2, that's minus 59x, then 330 divided by 2, that's 165, and this is equal to 0. So when we check, this verifies everything. Guys, it's a ding ding ding. This is the last part of the question paper. I'm very happy that we stayed all the way until the end. So this was nice, and I really appreciate you guys joining in on the questions. So this is where we're going to stop for the lesson. I hope you guys understand, and I hope you guys learned something from this lesson on how we attack exam past papers. So if this is your first time watching the lesson, make sure that you hit the subscription button, join the family, and we'll make sure that you feel at home. Thank you guys. I'll see you on our next lesson, which is Mathematics Paper 2 Past Paper.